STS, we're going to start turning on vent fans.
Copy that, EPD. EPD OTC 212. EPD here. Okay, they're going to be powering up the suit vent fans. Copy. CM2C OTC, step 410.
Copy.
CRC OTC.
This is COC.
Okay, I'd like to have you do step 422 by the clock, please. And there's a warning that that step must be completed before proceeding with the RJD driver switch activation.
And COC copies.
Okay. CNSC OTC 212.
OTC is CNSC.
Right. Need to have someone at your console empty the printer plotter baskets.
Copy, we got it, it worked.
Copy.
OTC, CDR, good morning.
Good morning, CDR. Welcome aboard. Read you loud and clear. Do we have any echo this morning?
No, sounds very good, thank you.
Okay, read you loud and clear.
OTC, CNSC 212.
Go ahead, NSA.
That's complete now.
Thank you much.
MTD, CDR, how do you rate?
So TC on 132, go ahead.
MTD, CDR, radio check.
CDR, NTD, good morning.
Good morning.
Okay, update on the balloon data. No improvement in sight at this time. However, as you know, we will continue to take data and count to 9 and then hold there for the window or the launch period or part of it.
Okay.
OTC, COC.
Go ahead, OSC.
Okay, step 422 is complete and you got to go on 423.
Copy. Thank you much.
This is Shuttle Launch Control at T-minus 2 hours, 14 minutes and counting. NASA Test Director Frank Merlino has just spoken to Commander Rick Hauk to let him know that the latest balloon data still is not satisfactory. It had improved just slightly. The next dump of the balloon data would be approximately an hour from now. We will continue to launch balloons as we go into the launch window, which extends until 1:41 p.m. Eastern Daylight Time today. The 1:41 cutoff being because of lighting at the transoceanic abort sites to ensure that there is satisfactory lighting for a landing, should a landing be necessary. In the White Room on the 190-foot level, suiting up of the flight crew continuing. Pilot Dick Covey already in the orbiter and being placed into his seat up on the flight deck. This requires adjustment of the seat, of the rudder pedals, to ensure that they are comfortable and he is able to reach them properly. Mission Specialist George Pinky Nelson in the White Room putting on his emergency gear over the pressure suit, and then he will be entering the orbiter to take his seat. He is going to be seated on in the mid-deck area, whereas the rest of them will be on the flight deck for this morning's launch.
Driver switches whenever you are.
Okay, we're not quite there yet. I'll give you a call in a minute.
Okay, copy that.
Pinky Nelson is another member of the STS crew to claim two hometowns, Clinton, Iowa, and Wilmar, Minnesota. He graduated from high school in Wilmar, earned a Bachelor of Science degree from Harvey Mudd College in 1972, and a Master and Doctorate from the University of Washington. He's an astronomer and has taken part in research at the Sacramento Peak Solar Observatory in Sunspot, New Mexico, University of Göttingen Observatory in Germany, and the Astronomical Institute of Utrecht in the Netherlands. The team in the process of taking off the boot protectors, and then he will be entering the orbiter and going into his mid-deck seat. The countdown clock at T-minus 2 hours, 10 minutes, 35 seconds in counting. This is shuttle launch control.
CGLS OTC 212.
CGLS, go ahead.
Okay, do we have a completion yet on SAP 92?
Negative, sir. That takes a little time. It should be maybe within a minute.
Okay, copy. Thank you.
CGLS 212.
Go ahead, DLS.
Yes, sir. I can report completion for 364 through 368 at this time.
Okay, all steps performed, right?
Yes, sir. All steps performed, and we'd like to go ahead and get a go for our initialization, please.
All right, at 2 hours?
Yes, sir. Per the clock, we'll need a quality on 183.
Okay, you have a go per the clock on initialization and CMQC OTC?
Go ahead, OTC.
Right, we'll need support on channel 183 for CGLS.
Copy. You can go ahead and give the verbal on that. The SEP dual interrupt notification will be activated momentarily.
Okay.
OTC asked.
Go ahead, ask.
We've run into a bit of a snag here with the PLT's vent fan power. When we turn on his vent fan, it does not come on. We've checked, we did power this guy up not an hour ago, I suppose. And I guess I'd like to get permission from you guys to just plug it in at a different DC utility outlet to make a quick check on where the problem might be.
Okay, EPD, OTC. EPD here. Yeah, do you have any problem with using another utility power output for the pilot's vent fan? It's their choice, whatever they want. Okay, and TP, OTC. TP. Okay, do you have any problem with a workaround solution for the pilot's vent fan? No, no problem. Okay, ask, do you have a go on that?
Okay.
CNSC, OTC 212. OTC is CNSC. Okay, the TAC anthem wheel setting for the tail side are 118 X-ray. Copy, sir. That's should be what we have set on there. Okay. That's per step 435, 436. Copy. So 437 will be a not perform, correct? That's perform. Okay, copy.
CMQC.
Go ahead.
435, 436, and 437 not performed?
No, 35, 36 complete. The fill-in is 118 X-ray, 437 not performed.
Copy.
And OTCS,
Go ahead.
okay, we tried routing the PLT's power cable to a different DC utility outlet. That did not solve the problem. This fan still doesn't work. Our next proposal would be to try just plug his fan box into another cord to see if it's the problem with the box.
Okay, stand by one, please. OTC, PD. Go ahead, APD.
Okay, have you checked the configuration of the circuit breaker and the switch to the utility outlet to make sure we're in proper switch configuration?
No, we have not done that.
Let me tell you that we plugged it into a different utility where the other fan was plugged in, and the other fan worked at that spot. And then also let me add that we tried this thing earlier and it worked fine.
OVCC, OTC.
Go ahead.
Yes, could you give us a reading on the O2 content in the white room?
It's over 20%. I can see it from here.
Copy that, thank you. Ask OTC.
Go ahead.
Okay, you're going to try another approach here with the pilot's suit fin?
Yeah, what we'd like to do is try and plug it in where take the fan box itself and plug it to the cord that would lead to MS1's fan box and see if it's the box.
Okay, why don't you proceed with that?
Okay.
OVCC, OTC.
Go ahead.
Yeah, we need to verify another item here, that the lock has been removed from the T-handle jettison box.
That's verified.
Copy that.
OTC asked.
Go ahead.
Okay, we've narrowed it down at this point to the fan box itself because plugging it in to MS1's power cable it does not work, whereas MS1...
This is Shuttle Launch Control at T-minus 2 hours and counting. Mission Specialist Mike Lounge is in the White Room now, preparing for his ingress into the orbiter Discovery. Mike Lounge's graduate degree is in astrophysics, astrogeophysics from the University of Colorado. And he served as a mission specialist on 51I with Dick Covey. He's a graduate of the Naval Academy at Annapolis, and he served as a radar intercept officer on an F-4J Phantom, participating in 99 combat missions in Southeast Asia during his time in the military. He was born in Denver, Colorado, but he considers Burlington, Colorado to be his hometown. And his parents still reside in Burlington. The process of getting the crew into the orbiter has been lengthened by the having them wear the pressure suits. The pressure suits, though, are part of the new safety system and the escape system, which would be possible from the orbiter in certain circumstances. The crew would be able to bail out if the orbiter could be put into safe horizontal flight at about 60,000 feet in the case of losing engines and not being able to make it to a landing strip which is capable of taking the orbiter either on during the launch process or on the entry process. And each of the crewmen over his pressure suit is wearing a parachute, carrying a life raft, having emergency rations and water and radio beacon, etc. At this point, the ground launch sequencer computer program has been started in the integration console here in the firing room. Engineers will now set up the specific tables in the launch processing system that the ground launch sequencer will use as its guidelines to either let the countdown continue or call an automatic hold when it assumes control of the countdown at the T-minus 9-minute mark. The status of the solid rocket booster retrieval area as reported to the landing and recovery director is favorable. The SRB recovery ships left Port Canaveral yesterday about 24 hours before launch. It takes them about 12 hours to reach the recovery station, which is about 150 miles east of the launch site. And once on station, they patrol the predicted impact area to chase out any ships that might be in danger of being struck by a jettisoned SRB. And then they're presently clear of the area.
Good morning, POT.
They are at an assigned station, which is 7.5 miles away from the predicted impact point. The countdown clock continuing at T-minus 1 hour, 56 minutes, 23 seconds and counting. This is Shuttle Launch Control.
MTD, PLT, how do you read?
PLT, NTD on air ground 1, how copy?
I've got you loud and clear.
Good morning. We get your fan going.
Well, right now it's not a problem, but I bet you an hour or so it is.
Okay.
OTC, TP. Go ahead, TP. Okay, the person who would know whether there are any spare fuses for the suit fans is a person by the name of Jim Schlosser, and he is presently located at the A11 roadblock. And OPC, see, have we confirmed that that it is the fuse problem? That's all the indications reported back from the crew compartment. All point to that problem.
Yeah, OTC, let me in.
Go ahead.
OTC, this is the ASP. I'd like to interject that that's the only thing that we can do next, because we're down to the box. It's either something internal to the box or the fuse itself.
Okay. Copy that. Thank you. TPH, you copy that? Yes, I did. Okay. Test one. VCC, OTC.
Go.
Okay, are you continuing with ingress of the other crew members?
Yes, sir, that's inboard.
Copy.
OTC asked.
Go ahead, ask.
Okay, I need to get some help with some circuit breakers so we can at least check and make sure none of these guys have popped. I'd like to know which circuit breaker drives the DC utility power on A11 and on O19.
Okay, you need to know the circuit breaker that drives the power, or utility power on A11 and O19.
That's affirmative.
Okay. EPD, OTC? OTC, EPD, it's in work. Copy that. We'll have that for you ASAP.
OTC asked.
Go ahead.
I have another bit of, I guess, bad information about these vent fans. We just tried to we tried to use MS1's vent fan to provide some air to the PLT, and now MS1's vent fan doesn't power on either. So that's two vent fans down. And a piece of information related to that is that MS1 and MS2's vent fans both are powered from the same DC utility outlet on A11. MS2's vent fan works fine.
Where is that? What panel is that powered on?
This is Shuttle Launch Control at T-minus 1 hour, 50 minutes and counting. The simulation of the first motion of the shuttle has been sent to the Johnson Space Center. Range safety and firing room tests are made of the system, which indicates the liftoff. This signal also starts the clock which keeps track of the mission time. Heaters in the solid rocket booster hydraulic control systems have also been turned on. They'll be used to start the decomposition of the hydrogen fuel, which is used to turn the turbines supplying power to the hydraulic pumps, which in turn allow the huge nozzles to be moved for steering purposes during the launch. In the White Room on the 195-foot level of the fixed service structure, astronaut Mike Lounge is still in the sort of the waiting mode to put on the rest of his equipment prior to entering the orbiter. We are working a problem there which has to do with the fan in pilot Dick Covey's flight suit. At the present time, we don't have a complete fix on whether or not the problem is in the suit itself. It appears to be in a pack which there is a spare for. At the present time, the vehicle itself is continuing down the path, going very smoothly. Weather is probably the biggest area of comment, looking at weather not only here at the Kennedy Space Center, but all over the world. The countdown clock at T-minus 1 hour, 47 minutes, 55 seconds and counting. This is Shuttle Launch Control.
CGSS OTC 212.
Go ahead.
Yeah, I assume you picked up your steps 480, 41, 42 by the clock.
I'll put those in the work right now.
Copy.
CMQC.
Go ahead, QC.
We need to identify a constraint for IPR 946.
It's step 16-411 POT portion of that.
Okay, it's a constraint to continue then?
Pardon me?
It's a constraint at that step?
That's right. We cannot get suit van power or the PLT, so it's a constraint against that operation.
Okay, copy. Thank you.
Okay.
OTC CGSS 212.
Go ahead.
Yeah, the accumulator force charge is complete.
Copy. Thank you. CMQC steps 480, 41, 42 complete. OTC APD. Go ahead, APD.
What kind of fuse are they looking for that fan box? Is it a bus type cartridge fuse or how many amps?
I'm not sure. Ask OTC.
Yeah, I'll check on that here.
Okay.
Okay, OTC TPE.
Go ahead.
All right, I guess we got words back that there are no fans available. However, we do have fuses available, but we don't know where they're at. And I guess the thing that we need to do is get in touch with this Mr. Slosser.
Okay, that's all in work, and we're trying to find out what type of fuse is required in the box. Waiting for ASP perhaps to give us that information. We may have a similar fuse that would work there.
OTC CDR.
Go ahead, CDR.
Okay, I'm going to read to you off the fuse. It's a bus type fuse, and it says fuse Mike Echo 451 -0009er -0003, and on the metal portion of the end cap it says bus 3. Over.
What was the last word, bus what?
3, number 3. I think it's a 3 amp fuse.
Okay, 3. Okay, we copied 2 ME 451-009-0003.
The first word is fuse, Fox Uniform Sierra Echo, then Mike Echo 451, etc.
OTC APD.
Okay, go ahead, APD.
Yeah, is it just a standard, it sounds like it's just a standard glass type bus fuse. Can they, is it ceramic or glass?
CDR, is the fuse ceramic or glass?
This is the CDR. It is a opaque fuse. It's not translucent. I'm guessing that it's ceramic, but I can't tell you for sure.
Copy.
This is Shuttle Launch Control at T-minus 1 hour, 40 minutes and counting. The launch team is tracking a couple of problems at the moment. On the air-to-ground loop, you've heard conversation about a fuse and about the fan. This is a fan which is located on the seat for the crew members, which provides cooling air into their suits. The fan is not hooked up to the suit until the crew member actually gets in the seat. The one for pilot Dick Covey is not functioning properly. There is a fuse in the box, which they are presently attempting to replace and to locate the replacement fuse for. At the same time, of course, we're continuing to track the upper level winds and try and determine whether the trend is in a satisfactory direction and if we're likely to get to a go condition prior to the closing of the window at 1:41 this afternoon. The ICE team, which was out at the pad surveying the external tank and the various connections to it, did come back and report on an S-shaped ice frost line on the external tank aft dome. This is about 10 inches long. They are in the process of evaluating whether that is a problem or not. The countdown clock continuing, the ingress of the flight crew taking longer because of the problem with the suit fan. We have only Commander Rick Hauk and Dick Covey on board at the present time, and we will. Because of the uncertainty of the window and the weather problems, we are continuing the countdown. We will go to the T-minus 9-minute hold point, and then we will continue to hold at that point, if necessary, to await the results of the latest weather balloons and to resolve any other problems which may arrive between now and then. The countdown clock at T-minus 1 hour, 37 minutes, 14 seconds and counting. This is shuttle launch control.
And we need to remove the guard on the RJD manifold L5, F5, R5 driver switch guard.
That's complete.
TP, OTC.
TP, go ahead.
Yeah, could you go 132, please?
Will come.
On panel 016F.
Go ahead.
On row F, RJDA2B, the L3, R3 manifold, driver switch on.
That's complete.
RJDA2A, the F3 manifold, driver switch on.
That's complete.
And the RJDF2B, F4 manifold, driver switch on.
That's complete.
And the right Ohms engine valve switch on.
That's complete.
OFC, OTC.
This is POC.
Okay, you want to pick up with your step on 430, please?
That's in work.
Copy that. And ASP on panel 06.
Go ahead on 06.
Okay, the GPC5 output switch back up.
Okay, that's complete.
Copy that. Thank you very much. CMQC, OTC. Steps on page 670 complete, 671 complete, step 433 complete, step 434 is not before.
I copy. And on step 429, was that switch guarded?
That guard was removed.
Is this reading incorrectly here then? GLS 212.
Go ahead, GLS.
Yes, sir. I'd like to report my GLS functional initialization is now complete. That was kickoff step 476. And I wanted to confirm that the contingency hold point at 1 hour and 20 minutes is going to be a non-perform.
Okay, we need to check on that. I'll get right back to you.
Thank you. QC and QC.
TP, OTC, 212.
STT 212.
Okay, the post-ingress switch reconfiguration is complete for step 438, and you can pick up step 439.
We copy 439.
OTCS.
Go ahead.
I'm ready for the caution warning volume adjust when you are.
Okay, ISL, OTC.
ISL.
Okay, we're picking up on the caution and warning volume adjust. The master alarm 099 is going to be tripped intentionally.
I copy.
Ask if you have a go on caution and warning volume adjust.
Okay, that's in work. And OTCS, the caution warning volume adjust is complete.
Okay, I copy that. And I have a request. Could you give us sort of a description of what activities you were doing when you discovered the problem with the pilot's suit fan?
Okay, yeah, sure can. We would just put him in the seat and connected the vent fan to the suit, which was all that remained, and turned the switch to turn it on, and nothing happened. Okay, then the next step, let me think here. We took his utility cord that was plugged into 019 and moved it over and plugged it into A11 and tried again, and still no joy. Then we disconnected his vent fan from the cord completely and connected it to MS1's cord and tried again, still no joy. So that was when we concluded it had to be the box. And then when we connected MS1's vent fan back up to his cord, to MS1's cord, his vent fan did not come on. And let me remind you that MS2 comes from the same power source as MS1, and his vent fan still works fine.
Okay, we copy that, Rick. Thank you very much.
You bet.
OTC, TP.
Go ahead, TP.
Okay, yeah, we'll verify 439 for you.
All right, thank you, Steve.
OTC, PD.
Go ahead, EPD.
We'd like to check the last set of numbers on that fuse up there again and see if that was 3 balls 3 or 1 2 balls 3.
CDR, OTC.
Roger, that was 3 balls 3.
It was a 3 balls 3. Very good, thank you.
Roger. And OTC CDR, I don't know if that's a serial number or a designator. It's printed on the, if it's ceramic, on the ceramic body with some kind of ink or paint.
Okay, we appreciate that information, CDR. OVCC, OTC.
Go ahead.
Be advised, there is a small aircraft in the area circling Pad B.
Copy.
Okay, they're security aircraft, in case you happen to hear their the noise.
Okay, thank you, sir.
This is Shuttle Launch Control at T-minus 1 hour, 28 minutes and counting. Mission Specialist Pinky Nelson and Mike Lounge have entered the orbiter, and Dave Hilmers is presently in the process of completing his suiting up for his ingress into the orbiter also. Dave Hilmers was born in Clinton, Iowa, but considers DeWitt, Iowa as his hometown. A brief picture there of a small aircraft that has violated the airspace here at the Kennedy Space Center, flying in the area around the launch pad B, still out at a little ways, but nevertheless in violation of the airspace. Dave Hilmer's presently ready to enter the orbiter. The closeout crew taking off the protective booties on his boots. Dave was a U.S. Marine pilot prior to joining NASA, and he logged more than 1,500 hours. He was named an outstanding scholar athlete in the Midwest Conference in 1971, and he graduated summa cum laude from Cornell College in 1972. He was selected as an astronaut candidate in May 1980 and completed his candidate training in 1981. In 1983, he was selected as a member of the Launch Ready Standby crew.
From the bid office, the recommendation is if the crew...
The countdown continuing, although we are working problems, including the suit fan for the pilot Dick Covey at the present time. Continuing to watch the weather very carefully. We expect to have another update from the weather balloon about 20 minutes from now. The countdown clock at T-minus 1 hour, 25 minutes, 35 seconds and counting. This is Shuttle Launch Control.
CMQZ, OTC.
Go ahead.
Okay, steps 547, okay, let me see here, page 695. Or do it not perform on those steps?
Whole page not perform.
That's firm.
Copy.
And also over on page 694, steps 540 through 543.
Copy.
Thank you.
OTC, suitable.
Go ahead, Douglas.
Yeah, I can verify 505.
505.
OTC, TPE.
Go ahead, TB.
Yeah, we showed picking up a master alarm here at 1307 Zulu, which was about 7 minutes ago.
That was the caution and warning volume adjust parameter 099 that the crew was doing.
Okay, very good. Thank you.
OTC, COC. Go ahead, OSC.
Page 672.
Okay, go ahead.
430, 431, 432, complete.
Okay, I copy. CMQC, OTC.
I copied that.
That completes page 672.
Copy.
OTC, MS1, radio check, air to ground 1.
Okay, MS1, OTC, air to ground 1. I read you 5 square. How many, please?
You're the same.
Okay, copy that.
OTC, DPS.
Go ahead, DPS.
Yes, sir. I'd like to go ahead and start picking up on step 550, the GMT Delta adjust.
Okay, you have a go on that.
OTC, TPE.
Go ahead, TP.
Okay, suggestion's been made about the possibility of removing the suit fan fuses and using the VOM that's used for verifying the hatch micro switches to verify the fuses are bad.
NTD, MS1, radio check, air to ground 1.
MS1, air ground 1, NTD, how copy?
Loud and clear, sir.
You're loud and clear also. Thank you.
OTC, CMQC.
Go ahead, QC.
We kicked off step 550 with DPS.
Yeah.
They didn't ask for CMQC coverage. Is that required?
CDPS, OTC.
Yeah, we can call those steps in when we're finished.
Okay.
OTC, CGNC.
Go ahead, GNC.
Would you like to get our QC set up on 141 for the pre-flight line?
Okay. CMQC, OTC, channel 141, please.
Copy.
And if you have a quality person, the other channel would be 152.
Copy. QC, CMQC.
Go ahead.
What are we doing on 141?
That's with CGNC. Let me give you the step number here. That's beginning with step 553.
Copy.
OTC,
OTC, VCC.
Go ahead, VCC.
Okay, we're checking these fuses at this time, and one of them is bad, and we're getting ready to check the other one.
Okay.
And it's no good.
Okay, 2 bad fuses. Copy that.
CC, GNC.
Go ahead, GNC.
Yeah, which CDS high track is supporting the current test? This prime.
LPS OTC. LPS OTC 212. CGNC OTC.
Go ahead.
High tracks CDS is Charlie.
Okay, thank you.
This is Shuttle Launch Control, T-minus 1 hour, 19 minutes, 57 seconds, and counting. The pre-flight calibration of the inertial measurement units, which started back at the 5-hour mark, have been completed. The systems engineer at the Guidance, Navigation, and Control Council reported that he was ready to proceed with the inertial measurement unit attitude determination as soon as the Greenwich Mean Time adjustment is complete. The mission timer can show either Greenwich Mean Time or mission elapsed time and can be adjusted within 1/1,000,000th of a second, either by ground command via uplink through the onboard computer or by the flight crew through the use of their flight deck display and control panel keyboard. The inertial measurement units are used to tell the guidance systems on the orbiter where it is in relationship to its launch pad here at the Kennedy Space Center. Each IMU contains 2 accelerometers to sense accelerations of the vehicle and 2 gyroscopes to provide a stabilized 4 gimbal platform to provide attitude and velocity information with respect to known coordinates. The navigation system used by the shuttle uses a standard reference point that's based on the position of the stars as they were at the time of the vernal equinox in the year 1950. The complicated process of aligning the inertial measurement units begins when the units are calibrated during the early part of the countdown, and the next step, the one about to be accomplished, is to make the transition from a calibration to an operational mode. The countdown clock continuing at T-minus 1 hour, 18 minutes, 5 seconds and counting. This is Shuttle Launch Control.
DPS 212. Go ahead, DPS.
Our GMT and MET delta adjust is complete, and on step 551, the GMT delta adjustment was -1 millisecond. And the MET, we had a delta of plus 16 milliseconds and did not adjust.
Okay, I copy. GMT delta adjustment is -1 millisecond. The net delta adjustment is plus 16. You would say no adjustment is necessary?
Affirmative.
Copy. And so you're ready for step 552?
Affirmative.
Thank you. And CGNC OTC.
Go ahead.
Okay, we have a completion on step 552. You have a go on step 553 and also your IMU portion on step 554 per the clock.
Okay, we can verify 553 and we'll pick up 554 by the clock.
Copy that.
OTC, OBCC.
Go ahead.
Okay, sequence 16585. The water valves on the 215-foot level have been closed.
Okay, copy.
Thank you.
OTC, CDR.
Go ahead, VDR.
Roger, several of us would like to breathe up our suits right now. We understand that's not a problem.
No problem whatever.
Okay, we're doing that.
OTC, NS2, radio check, how do you hear?
NS2, OTC here, read you loud clear, help me.
Have you the same?
Okay, copy that.
NTD,
MS2 on air-to-ground, how do you hear? NTD MS2 on air-to-ground, how do you hear?
MS2, I read you 5 by. How many?
Have you the same?
Thank you.
CBSE, OTC 212. CBSE, go ahead. Right, I was looking at step 489. Is that enough to form on that step? Roger, there'll be no instrumenting crew this time. I copy that, thank you very much. Roger. OVCC, OTC.
Go ahead.
The replacement fuses are leaving the A11 roadblock at this time.
Okay, thank you, sir.
The container has three 3-amp fuses and 3 5-amp fuses.
Copy. Would you like me to send a tech down to the top of the pad? We have the elevator locked out up here on this level.
That's affirmed.
Okay, thank you. We'll watch for them and send somebody down.
Okay, copy that.
This is Shuttle Launch Control at T-minus 1 hour, 10 minutes and counting. We have just had word, for those of you who are listening on the net, that the fuse that they're waiting for to try in the cooling fan, which is used for the cooling of the flight suits, has arrived at the roadblock and is going to be taken out to the pad. The cooling fan is actually a separate unit which is hooked up to the flight suit once the crew enters and sits in the seat in the orbiter. And this particular one is used for cooling the flight suit of pilot Dick Covey. At the present time, we are standing by to see whether that works. All of the crew members have gotten into the orbiter and been placed in their suits and are in the launch position at the present time. Weather, of course, is the primary concern that we have this morning as we go through the countdown up to the T-minus 9-minute point. We launched 2 additional weather balloons which go up to the 100,000-foot level. The one is at 8 o'clock this morning and the other at 8:45, and we will receive the information back about 10 o'clock from the first one. At the present time, the earliest possible launch time is still 10:59. It would take a significant trend in the right direction to make that possible, or actually a condition change in which the conditions were satisfactory based on the present weather balloon. We have just had a data dump from the ICE team, which was out on the pad. It appears that we will not have any problems with what they saw, and in almost every case, the conditions were about the same as they saw during the flight readiness firing and fall well within the guidelines. The pad was reported to be extremely clean with no debris that would be a problem at all. They are in the process of taking an examination of one particular S-shaped ice cross line on the ETF dome and determining whether that would be a violation of the criteria or not. The countdown continuing at T-minus 1 hour, 7 minutes, 3 seconds and counting. This is shuttle launch control.
About the crew comfort, are you working that situation out there?
Yeah, everybody seems to be okay.
All right, we copy
No
that.
complaints. They're a good bunch of guys.
Okay, we copy that. Thank you very much. Well, NTD or OTC launch director, most concerned about the people on the right-hand side that are in the sun, Big Covey, and if there's anything we can do to help the heat factor there, we ought to be doing that. That's all.
Launch director, PLT, we got the sunshades up in the windows, and that's keeping it cool enough in here to make it okay.
Okay, copy. Well, if you need anything, let us know.
We'll holler.
Okay, CMQC, OTC, go ahead.
I want to let you know that our constraint at step 828, line 476, has been removed.
I copy that, thank you.
Hey, CCME.
Go ahead, CCME.
Yeah, I'd like to pick up with step 575. We'll need LPS support.
Okay, you're going to be working with CSME on that.
Yeah, and then would like to go over to 146 and work that.
Okay, yeah, you have it going. We'll get LPS over on 146.
COC on 171, go ahead.
OVCC, OTC.
Go ahead.
Okay, the fuses on the vehicle have just gone past the pad gate.
Thank you. My tech is going down to receiver.
Copy that, thank you much. CCNC, OTC. Go ahead. Yeah, they go on step 565 for the clock. Copy, thank you.
OTC,
Go ahead, ask.
Okay, we're pretty much done in here except to swap out the fuses, then pull out the panels behind me, so I'm going to just be here on comm until they get here, until the fuses are out.
OTC, CCME.
Oh, great. Stand by, CCME. Okay, as you say, you're going to stay on comm until the fuse problem has been resolved?
That's a firm.
Copy that.
This is shuttle launch control. We're coming up on the 1 hour point in our countdown.
Come over to 146.
Just about 30 seconds away from that. The pre-flight alignment of the inertial measurement units started on time about half a minute ago. The pre-flight alignment will be completed during the hold at the T-minus 20-minute point, just before we put the onboard computers into their final countdown configuration. The pre-flight alignment cannot be completed more than 10 minutes prior to the computer transition to what is called Ops 1. This occurs when we come out of the T-minus 20-minute hold. However, if it's delayed longer than 10 minutes allowed, then the pre-flight alignment must be performed again. The solid motor chamber pressure tests began about 30 minutes ago, and they have been completed now. And safety officials have confirmed that fire and rescue personnel will be on station at the shuttle landing facility and just outside the pad blast danger area by T-minus 30 minutes. Launch Director Bob Seek talked to pilot Dick Covey just a short time ago, concerned about the fact that he is on the side of the orbiter which is facing the sun, and he is the person whose cooling fan for his suit is not operating presently. New fuses for those fans are at the pad now, and we should know in a very short time whether that's going to fix that problem or not. We're still standing by for additional weather data and are hoping to hear in just another 20 minutes from the the 8 o'clock weather balloon. The countdown clock at 58 minutes, 30 seconds and counting. This is shuttle launch control.
OTCSD 212.
Go ahead, SV.
Yes, sir. You've got to go for the 5 amp fuses.
Okay, we're also in contact with Mr. Schlosser at this time, and we'll confirm that with him also.
I copy. Thank you.
Okay. Okay, ask OTC.
Go ahead.
Okay, you have a go for replacement of the fuses with the 5 amp fuse.
Okay, that's in work. Okay, we've got one fan working, and I'm going to put the fuse in the other fan.
Okay, we copy that.
CCME.
Go ahead, CCME.
I want to report completion on step 575.
Okay, copy, thank you.
OTC asked, we've got all fans up and running.
Okay, very good news.
OTC asked.
Go ahead.
When you're ready, I'm going to disconnect myself from comm and leave.
Okay, stand by just one. All personnel, we need to verify at this point that all systems are ready for crew module close-up.
OTCSD.
Good SB.
Yes, sir. For the ASP, are you going to stow the extra 5 amp fuse with the crew?
I was just going to ask somebody if I should do that. The crew would like it. I'm going to ask for it.
OTC, let us go over and ask flight. Stand by.
Yeah, that's in work on channel 232.
I copy. Thank you.
OTC, CCFC.
Go ahead, CCFC.
Okay, we're wondering if you'd, before we close the hatch, if you want to put your astrocom checks into work that are on page 690, starting with step 518.
Yeah, we're aware of that.
Okay.
We won't close the hatch until that's complete.
Copy.
And OVCC, OTC.
All right, go ahead.
Okay, do we have all the items from the crew module listed on step 516?
Almost. I still got the O2 meter and the circuit breaker panel still in there.
Okay.
This is shuttle launch control at T-minus 52 minutes and counting. The replacement of the fuses in the 2 suit fans which were not operating properly has been completed. The fans are running, and those fans were for pilot Dick Covey and mission specialist Pinky Nelson. There are additional fuses, 5 amp fuses, which are being stowed on board in case there should be a need to replace them in the future. And there are some 6 amp fuses which also will be placed on board that have been approved for use if necessary in an emergency. In the meantime, the astronaut support person, Rick Heeb, is in the process of completing the closeout of the flight module. He has to remove a number of items which are used for the ingress procedures that are not needed during the flight. For instance, they take out the switch guards which were placed over the various reaction control and ohms engine switches, the visor protectors that are used on the launch and entry helmets that are worn by the crew, flight data file stowage bags, some personal equipment transfer bags, the procedures which he uses when preparing the cabin, and various tools that might be used in the adjustment of the seats and the rudder pedals and the other things which are necessary for ensuring that each of the crew members is comfortably seated for the launch into space. We are continuing to wait results from the weather balloons to see whether we will be able to go this morning. The countdown clock is proceeding, though, towards the T-minus 9 minute hold. Actually, we'll stop at T-minus 20 minutes for 10 minutes. but then we would pick up on time and go down to T-9 in order to not have to go through the realignment of the inertial measurement units. The countdown clock at T-minus 49 minutes, 38 seconds and counting. This is shuttle launch control.
Activation's complete. I copy that. HYD water spray bladder activation complete.
Okay, copy. Can verify step 592.
RSRE OTC 212.
RSRE, go.
Okay, step 598, start the mag tape and strip charts for the SRSS terminal count test.
I verify they are started.
Thank you.
593 complete.
CGLS OTC 212.
Let's go.
Okay, at the clock, perform the GLS mainline activation.
Yes, sir, we'll report completion to you.
OVCC, OTC.
All right, go ahead.
Could you give us another reading on the O2 content, please?
Oh, Roger, I'm looking right straight at it. It's over 20%.
Okay, we copy. DPS? DPS. 647, 648 complete. Okay, we copy. OVCC, OTC.
Go ahead.
Okay, the
This is shuttle launch control at T-minus 45 minutes and counting. We're just about to go into the communication checks between the crew members, first the commander, then pilot, then the 3 mission specialists in the orbiter, and they will first check their communications with the on the single links between the orbiter and the control center here and the mission control center in Houston. And then after they have completed those, they do what's known as the SIMO voice checks, which you'll be hearing them talking about on the loop, which actually make use of 2 links and the simultaneous or backup systems that are used to communicate. The process of closing up the crew cabin is still underway, and it's necessary to go through the initial part of those voice checks prior to closing the hatch, which normally would be done at this point. Once the hatch is closed, then the commander, Rick Hauk, will be asked to perform the first of a couple of cabin leak checks. In the meantime, we'll continue down through the countdown to the T-minus 9-minute hold, and there's a pretty good chance that that could get extended if the work has not been completed by that time. Of course, our main concern is the weather still, the fact that we have balmier conditions at altitudes here, and also winds from the wrong direction compared with the type of trajectory information that has been programmed into the computers at Houston and in the orbiter for the flight. The whole problem is that you want to keep the stress at a minimum on the orbiter as it flies up through the atmosphere, and you need to have the engine steering exactly right and the aero surfaces taking advantage of the type of winds that it was programmed to be seeing, which are the type that we normally have at this time of year. But the countdown clock proceeding at this point, T-minus 42 minutes, 28 seconds in counting. This is shuttle launch control.
At the moment, I'd like to give an update. Okay, CDR OTC.
Roger, we're listening.
Okay. CDR, this is STE. Just a reminder, with the potential increase in cabin pressure, you may experience a caution warning parameter 004 and a BFS caution warning message on the fault sum page, SM1 cabin pressure after you close your visors and turn on the O2.
Okay, we appreciate the letter.
Thank you, OTC.
OTC, TBC. Go ahead, TBC. Step 652 is complete. Copy that, thank you. CDPS, OTC?
SDPS.
Okay, we're ready for 653.
Copy. 653 through 657 are complete.
Copy. CCSC, OTC.
OTC, this is CCSC.
Right, I guess they're need you on channel 232 for the high power.
Copy, I've already talked to NTD.
Okay, RCRE, OTC. Okay, OVCC, the vehicle just passed through the pad B gate.
I copy. I got people downstairs to retrieve them.
Okay, well, very good.
CCC, GLS 212.
Go ahead, GLS.
Sir, GLS pre-sequencing has started. That's step 58 and 59. That's 658 and 659.
Okay, we copy that. Thank you.
MTC.
Go ahead.
The constraint at step 514 has been moved to step 517, line item 386.
OTC, CDR.
Go ahead, CDR.
Roger, several of us are going to breathe up our suits again.
Okay, you have a go on that.
Thank you.
OTC, ECL 212.
Station calling, repeat, please.
Yes, ECL.
Yeah, go ahead, ECL.
Yeah, just be advised that because of the delay in closing the hatch, our leak check is probably going to run into the 9-minute hold.
We realize that.
Okay, thank you.
Okay.
Will that be good?
OTC.
OTC, PLT on air to ground 1.
Go ahead. Go ahead.
Roger, got an apparent disconnect between the OMI and our ascent checklist pertaining to the APU tank valve enable circuit breakers. According to our checklist, ascent checklist, they should be closed at this time, and at the APU pre-start in 6 minutes, we would just verify that they were closed. They are, by the OMI, currently configured so that they're open. I just want to get a confirmation from y'all as to what the right time is to close them by your OMI, and and when to do that.
OTC, VCC.
Go ahead, VCC.
Okay, we have the fuses here, and we're putting them in the crew compartment this time.
Okay, we copy. APU, OTC.
This APU.
Yeah, did you copy that comment from the crew on the circuit breakers?
Yes, I did. Per the OMI, it was in step 991 of sequence 16 during the pre-start. That's where we closed. We're in the proper position right now per the OMI. If the CDR or the PLT, that is, has a preference for having them closed right now, we don't have any problem with that.
OTC, PLT, I don't particularly care if they're closed now or not. It's just that my checklist doesn't ever have me close them. It just has me verify them closed. I just want to know if that's the point at which the OMI wants them closed.
That is firm. That is correct.
Okay, OTC, PLT copies. I will close those circuit breakers during APU pre-start at 6 minutes.
Okay, we copy that. Thank you. Launch Director, OTC, are you on 212 here? Roger. Okay, we're ready anytime, Bob. Okay, for the benefit of the crew and those on air to ground 1, the latest Wednesday, the loft did show some improvement. We're still a little bit out of spec, but it's getting better, so that's encouraging, and we ought to have another set of data here within the hour. Our local weather is still holding, and we still have one PAL site hanging in there. So weather-wise, we're still looking pretty good, enough to hang in there anyway, and in terms of our timeline, although we're behind due to the problem there with the suit fans, we're going to go on down the hold at 9 minutes and catch up there on the closeout.
Sounds good to us, Bob. Thanks.
I copy. Well, we're still pressing along. Stay Okay,
Well, we don't want this thing to leave without us.
OTC ask.
Go ahead, ask.
Okay, I've stowed the circuit breakers in MS2's pocket, and I'm about to back out of here when you give me the go.
Okay, and ask an OVCC, we need to verify all items have been removed from the crew compartment at this time and properly recorded.
Roger, we'll put that in work.
Yeah, copy.
And when that's complete, ask you have to go to egress the crew compartment. And mid-deck needs to be inspected and report any items that you remove from the crew module.
Okay, we're down to just me and the circuit breaker cover and the O2 meter and my headset.
Okay, we copy.
OTC, CMTC.
Go ahead.
If he can give me those tier log numbers, other than that, we can get rid of that constraint.
Okay, you need the tier for those three items there?
That's correct. That's what's holding that constraint up.
Okay, we understand. VCC, OTC.
Go ahead.
Yeah, there's three tier numbers here we need to verify. As soon as you have those, we'd appreciate that.
Roger, my QC's coming up on the net.
Okay, what are they? Which ones are they?
Oh, wait, the RHC covers left hand and right hand.
Roger, that's the element removed.
Say again, please.
They're removed.
Yeah, we need the tier number.
Oh, okay.
CDR, OTC, air to ground 1. CDR, OTC, air to ground 1.
Go ahead.
Right, at this time I'd like to have you perform the pass and BFS transfer prep.
Can work.
OTC, that's QC.
Okay, I copy, complete.
This is NASA quality. The PIR number for the hand controllers is FO749. That is clear.
SO739?
Fox 749.
Okay.
Okay, which one are
Flight deck O2 meter.
That's the Fox 0833. That's complete.
Fox 0833 and the mid-deck O2 meter.
OTC, CDR, pass BFS transfer prep is complete.
We copy CDR. Thank you very much.
That's it. That's the one we have.
OTC, VCC.
Go ahead.
Okay, we have everything out of the crew compartment. The aft is out. Do we have a go to close the hatch?
All TRs are closed out.
No, do not close hatch yet. Was there just 1 meter inside?
Right.
That was on the flight deck, right?
Right.
Okay, CMQC, we'll delete that subset 16 then.
All right, there's no mid-deck O2 O2 meter.
That's correct. So does that take care of that constraint there now?
This is shuttle launch control at T-minus 30 minutes and counting.
Step 829.
We're continuing to go through the various steps, although some of them, which normally would be completed at this time, have not been. Normally we would have the hatch closed and would have completed the astronaut voice checks. Those have not yet been done. And also we would have turned the S-band antenna to its high bit rate. The launch team is waiting for the results of the 8 o'clock balloon run to see if there has been any change in the upper level winds. At the same time, analysis is being done of the ability of the orbiter to fly with the winds as they are at the present time, and we're standing by to hear that.
The appropriate volume control, air to ground 2.
We do not appear to have any problem now with the cooling fans that are used for the suits on board the orbiter, and the removal of material that is not needed in the cabin is basically complete at this point. In just a few minutes, we should see the closing of the hatch, and that would be followed by the beginning of the cabin leak checks and the other tasks which need to be done by the flight crew. We're just about 8 minutes away from the T-minus 20-minute build-in hold. This is a 10-minute build-in hold, and there will be a second 10-minute build-in hold at the T-minus 9-minute point. There's a good chance that will be extended at that time. The countdown clock is proceeding towards a launch at 10:59, but at this point, we would have to proceed pretty fast in order to make that time. The launch window extends to 1:41 this afternoon, so there is time to complete the task if the weather is going to cooperate with us. The countdown clock at T-minus 27 minutes, 23 seconds and counting. This is shuttle launch control.
CDR loud and clear.
PLT, MS1, MS2, MS3.
This is the OTC. I'm getting a slight echo on your transmission.
Well, we don't have one. Sounds good on this side of the boat.
Okay, this is the OTC. I'll be returning to air-to-ground 1 at this time. CCSC, OTC.
Yes, OTC. The echo you're hearing will be there if you have both UHF and an air-to-ground or ICOM monitor up at the same time. The delay between UHF and the air-to-ground have been zeroed out for both the flight crew and Houston flight.
Okay, so that's it's a situation that is normal.
That's a problem.
Okay, we copy that. Thank you. CCME, OTC.
CCME, go.
Right, the performance of the RF FEP source verification on channel 128, you have a go on that.
Thank you.
OTC, CTLS 212.
Discovery, Houston. For PLT and CDR, configure for air-to-ground 1 voice checks.
Hotel.
Discovery, Houston. For CDR, how do you read? Air-to-ground 1.
Loud and clear.
PLT, how do you read,
PLT,
Houston?
loud and clear.
Roger, configure for air-to-ground 2 voice checks. Discovery, Houston on air-to-ground 2. CDR, how do you read?
Loud and clear. PLT's loud and clear.
Roger, configure air-to-air ground checks.
Sorry about that. I just wanted to report completion on SEP 700.
Discovery, Houston on UHF, how do you read CDR?
Loud and clear. PLT's loud and clear.
Roger, got you the same. Configure for simul voice checks. Discovery, Houston, simul voice checks. CDR, how do you hear?
Loud with a significant echo.
Copy loud with a significant...
PLT's the same.
MS1, how do you read Houston?
Loud with an echo. MS1.
MS2, how do you read Houston?
MS2, I see the same.
And MS3.
You're loud with an echo, JO.
Copy loud with an echo.
Okay, and JO, during your checks with the MSs, I deselected air-to-air, and the echo is between air-to-air and the air-to-ground 1 and 2 loops.
We copy that, and be advised, based on the L-2 hour balloon, there are no updates on your performance cue cards.
OVCC, OTC.
Go ahead.
Okay, you have a go to close edge.
Thank you. That didn't work.
DPS? Right, DPS, you're looking for step 724.
Sir.
Okay, CDR OTC.
Roger.
Okay, on CRT3, can you verify an item 25 with no asterisk?
That's verified.
Copy that, thank you. CDPS?
DPS, copy, thank you.
Okay.
CCCME.
Go ahead.
Want to report completion of step 675 and 676.
Discovery Houston, over.
Okay, we copy.
Roger.
Rick, I'm going to give you a long count and see if we can't adjust these voice loops to get rid of the echo. Long count follows. 1, 2, 3, 4, 5, 6.
This is Shuttle Launch Control at T-minus 20 minutes, 48 seconds and counting. We're just a few seconds away now from the T-minus 20 minute hold, and we will stop the clock at that point. The launch crew has been going through voice checks with Houston, and they're testing their capability to communicate with the Mission Control Center, and we have had a go for the closing of the hatch. The closeout team working very quickly on the hatch securing. Once they have actually gotten the hatch closed, then they have to put in insulation plugs. Coming up on the T-minus 20 minute point, T-minus 20 minutes and holding. This is a 10-minute build-in hold, and we will come out of this hold and continue to count even if we do not have all of the tasks done that need to be done up to this point. Then we will count down to the T-minus 9-minute point, which is another planned hold, and we would hold as long as necessary in order to complete the work. During this T-minus 20-minute hold, all of the computers in the firing room or control room are configured with proper programs for the final portion of the countdown. When we come out of the hold, Discovery's onboard computers will be transitioned into the Ops 1 configuration, which is the terminal countdown configuration. Also during this hold, the orbiter's inertial measurement units will complete their pre-flight alignment and will go into the inertial mode. Biases or corrections to account for the Earth's rotation between now and launch time will be factored into the navigation units until T-minus 12 seconds, when the biases are removed and the IMUs go full inertial. The countdown clock at T-minus 20 minutes and holding. This is Shuttle Launch Control.
CGLS OTC. CGLS OTC 212. CGLS OTC 212.
Yes, sir, this is GLS. Go ahead.
All right, can you verify step 744 and confirm, please?
Yes, sir, I can verify that. Thank you.
Okay, and CVFS OTC.
Go ahead, OTC.
All right, VFS step 745, receipt of the software authorization for flight per, and the other RAS number.
Yes, it's 026.88.
026.88.
That's correct.
Thank you. AFM OTC.
At OTC.
Yeah, AFM, need to have you pick up on step 746.
Copy that.
And COEX OTC.
COEX, go.
Right, step 755, activated D-mines for Oasis BFS discrete measurements.
Copy, that's complete, sir.
Thank you. All personnel in the firing room, we need to verify the console software is properly configured for T-minus 20 minutes. CSME.
That's me verified.
CMPL.
MPL verified.
CMPS.
MPS verified.
CCSE.
CSC verifies.
CNSC.
NSC verifies.
CPVD.
PPD verifies.
CECL.
ECL verifies.
CFCP.
SCP verifies.
CGSS.
CGSS verifies.
CAFM.
CAFM verifies.
COOS.
COOS verifies.
CHYD.
CHYD verifies.
CATU.
ATU verifies.
CISL.
ISL verifies.
CHTD.
CHTD verifies.
CEPD.
EPD verifies.
OFC, AFC, and GNC.
Can we verify?
Copy, and DPS.
DPS verifies.
CCME.
CCME verifies.
And would you pick up the D there, CCME, please?
Put that into work now. Report complete. When I'm finished.
Okay. And GLS, can you verify programs?
GLS verifies.
And CTPE, 2 concurrencies and also the programs that back up.
PP verifies.
Copy that.
OTC, CSCT.
Right, FCP.
Yeah, we haven't received CMQC coverage yet.
Okay. CMQC, OTC.
What channel was that again?
153. Also on 151.
Copy.
OTC, CSCT.
Go ahead.
We'd like concurrence to pick up with the clock.
You have it.
OTC, AFM.
Go ahead, AFM.
Yes, per step 0748, use of launch data bus is complete. Star tracker door open indications are verified off.
Copy that. Thank you.
I got a
OTC, COSC.
Yeah.
Go ahead, OFC.
On page 725, can we get a go for step 682?
How about E&M? The other one?
Yes, you have a go.
Okay, that's for LPS also.
Thank you.
OTC, SB 212.
Go ahead, SBE.
Did we complete the O and 2 first pressure?
Yes, we did.
Okay.
Yeah,
thank you. OTC, EPD.
Go ahead, APD.
Okay, we never got our CMQC on 151 for the fuel cell adjustment.
Okay, CMQC.
We're on the way right now.
Okay, thank you.
OTC, VCC.
Go ahead.
Okay, we'd have the hatch closed this time. We're ready to do the 2 PSI leak check.
Okay, we copy that.
And OTC, SB.
Go ahead, SBE.
Yes, sir. Just a reminder for CDR, because we're late, if he sees anything other than what's on his checklist, if he'd let us know when we transition to G1.
Okay. CDR, did you copy that from SBE?
That's affirmative.
Okay. And CDR, we'll be doing the cabin leak check at this time on panel L2A1, please.
Roger. Cabin leak checks in work.
Okay.
OTC, CMQC.
Go ahead.
This is shuttle launch control at T-minus 20 minutes and holding. We have just about 3 minutes left in this build-in hold before picking up the countdown again at the T-minus 20-minute point. The commander, Rick Hauk, has been asked by the NASA test director to begin the cabin leak checks. The hatch has been closed, and the team is in the process of removing the handle that's used during this phase, and now they will be putting in insulation plugs to cover up those areas and protect them during the flight through the atmosphere and the return. All of the system engineers have reported back that their respective test conductors that the proper programs are running in their consoles and that their systems are operating properly. The landing and recovery director, Ron Phelps, has verified that the landing convoy at KSC is ready to support the launch, along with teams at all of the possible landing sites. We have had a report on weather at those sites, and of Marone and Ben Guerir, Marone appears to be the most satisfactory if a board should be necessary. However, it does have some smoke blowing onto the runway as a result of farmers who are burning their fields at this time of year.
Okay.
The NASA test director, Frank Merlino, is going to normally does a briefing about the recycle options at this point. but he is going to hold that for the T-minus 9-minute hold.
Cabin leak checks in parallel with that.
Understand.
We are just about a minute away from resuming the countdown once again. We have just had word from Frank Merlino, the NASA test director, that the clock will resume on his mark just about 40 seconds from now.
Cabin pressure. CDR. OTC, we get a cabin pressure.
We've just had a report that the hatch seal leak check has been completed and that it passed. And this was a constraint to doing the cabin leak check.
CDR, OTC.
This is MS2 reading panel 01.
Just 10 seconds away from picking up the countdown once again.
EDT is 0.
Okay, we copy 14.5.
And T-minus 20 minutes and counting.
ECL, you copy? Yeah, we copy that. Thank you.
OTC, CMQC.
No more QC.
OTC, CTVD.
Standby, PVD. Okay, all personnel after transition ops 101 that discontinue all launch data bus PMU reads for the remainder of the countdown.
OTC, DPS.
Go ahead, DPS.
Yeah, pass ops transition is complete. We're ready for VFS transition to ops 101.
Coming up on the 19-minute point in our countdown, T-minus 19 minutes and counting. We have just heard that the redundant set computers on board the orbiter have transitioned to the OPS-1 program, and also that the backup flight software also has transitioned properly.
Okay, we copy that. Thank you. OTC, LPS 212.
The purge of the 3 fuel cells is underway. The data processing engineer has confirmed also that the onboard computers have made the transition. Coming up on the 18-minute point in the countdown. T-minus 18 minutes and counting, continuing to move through the various checkpoints here in the countdown, and that's exactly what a countdown is. It's simply a list of the steps that you have to go through in order to launch a shuttle.
Yes, AFM, go.
Yes, can I communicate with OVCC on hatch seal leak check?
Yes, go ahead at this time.
OVCC, AFM, could you tell us what the leakage rate was for the crew hatch?
Oh, it was 0. We put in 15 PSI, we waited a minute, and it was 15 PSI, so we had no leakage.
I copy that. Thank you very much.
That was fuel number 1 unit we used.
Copy that.
Discovery Houston, over.
Roger.
Rick, would you say that the current echo is acceptable, or would you like us to try and tweak it one more time?
JO, it's not acceptable, but I suppose you might come up to us on either air-to-air only or air-to-ground 1 and 2 only.
Okay, we copy that as a workaround, but let's try and tweak it one more time. And this time, when I give a long count, if you would sing out when it gets better, then we'll stop the adjustment at that point. Long count follows.
Okay.
1, 2.
At the present time, Houston in the process of trying to solve a problem with an echo which Commander Rick Houck is getting on his communication system. The countdown clock at T-minus 16 minutes, 20 seconds and counting. Dumping of the OPS-1 program stored in the memory of one of the 4 redundant general-purpose computers has started, and this takes approximately 7 minutes to complete, after which engineers will examine the data for any miscompares. The airframe engineer is in the process of checking critical aerospace driver currents and positions in preparation for hydraulic activation.
1, 2.
Hydraulic activation occurs when the auxiliary power units are turned on at the T-minus 5-minute point.
8, 9, 10, 9,
Right there.
8. Copy right there.
Okay, now let's just tell us how the weather at Ben Greer is so if we can understand it.
Okay, the latest estimate at Ben Greer is currently no-go for crosswinds. Our current thinking now is that we'll be using Marone as a TAL site. How do you read?
Okay, that's very good. I think that'll work, and
okay, we're copying you loud and clear.
OTC. Roger. And OTC MS2, we just had our klaxon. We've got about .32 DPDT, and we're showing about 15.4 on cabin press.
Okay, 15.4, and what was that, .22?
We're about .32 when we got the alarm.
Commander Rick Houck getting an update on the weather at the TEL sites, and that Ben Greer is no-go at this time. Ben Greer in Morocco is the primary transoceanic abort site. Marone is the backup, and the current thinking is that Marone will be satisfactory. The countdown clock at T-minus 14 minutes, 8 seconds, and continuing to count. The data processing engineer reported that the backup flight system is in synchronization with the primary system.
CDCVSS?
Yeah, VFS NTD is on channel 232. Do you have a problem?
No, I just wanted to give him step 870.
Okay, there it is. Still on channel 232.
OTC, CFCT.
Go ahead, FCP.
Fuel cell purge is complete, ready for fuel cell load adjust.
All right, you have a go on that. EPD copies.
OTC, Cedar Boss.
Go ahead, that was.
Yeah, steps 882 through 886 were completed per the clock.
All right, I copy. Thank you.
Coming up on the 13-minute point in our countdown, the booster test director has been asked to start the gaseous nitrogen purge of the aft skirts and the solid rocket boosters. T-minus 12 minutes 40 seconds and counting. We're getting an update to the TACAN at Marone, since that is going to be primary now. The TACAN is a navigational system which is used by the orbiter, also used by aircraft in the landing process.
CPLT horizontal sit config is complete.
The purge of water from the onboard fuel cells has been completed. Water is a byproduct of the production of electricity by combining hydrogen and oxygen in the fuel cell. T-minus 12 minutes and counting. And although the water is used for drinking water in orbit, it cannot be allowed to build up too far. The fuel cell electrical loads are now being adjusted to between 250 and 290 amps.
OTC, MS2. OTC, CDR. Houston, how do you read Discovery?
We read you loud and clear, Discovery.
We've apparently lost our link with OTC.
We copy, and can you confirm that you have set in Area 3 on Spec 50?
Coming up on the 11-minute point in the countdown, the Landing and Recovery Director, Ron Phelps, verifying that all contingency support operations are ready for launch and emergency aircraft and personnel on station.
Okay, Houston, we have Area 3 selected for the site, and we'll try to get these back in some wheels. We might have to do it if we need it.
Copy.
OTC, CDR. We apparently lost you for about a minute. Loud and clear now, sir. We lost you for probably a minute and a half in there.
Well, you're good on air to ground 2. I'm going to try you one more time on air to ground 1.
T-minus 10 minutes, 16 seconds and counting. We're coming up on the 9-minute build-in hold. At this point, we're approximately a half hour behind in the activities that are being completed for launch. The 9-minute hold is normally a 10-minute one. However, we can hold at this point for a considerable length of time.
And PLC, we need to have you configure the ohms interconnect.
NASA Test Director Frank Merlino asking that all of the test team personnel switch to a common channel, which they will remain on through the balance of the count. In that way, each one of them is all getting the same information. Prior to this point, they have been on separate channels in order to work the various activities associated with their functions. 15 seconds away from entering the built-in hold at T-minus 9.
Fuel cell load adjust is complete.
And we've had verification that the fuel cell load adjust is complete, and we are at T-minus 9 minutes and holding.
T-minus 9 minutes and holding.
As we come out of the hold, the ground launch sequencer takes over control, issuing commands for the final critical tasks and monitoring as many as 1,000 different measurements during the final 9 minutes of the count. During this count, which we expect to be extended, we'll be listening for the completion of work which has been underway. The countdown at T-minus 9 minutes and holding. This is shuttle launch control.
OTC, CCME.
Yeah, CCME.
I want to report 912, 913, and 915 complete, 914 not performed.
Okay, we copy.
And RSO NTD, check 212.
NTD, this is RSO on 212. I read you loud and clear. How me?
Bye-bye. Thank you. And HGD, CGSS, GBSX, code 232, check.
OTC, PLT, MPS helium reconfig complete. Stand by for your report on the RCS quantities.
Okay, we're ready for the quantities at this time. Okay, we copied 70069er on the forward oxidizer and fuel, right? And on the left oxidizer,
what is that?
Say again.
Roger, was forward was oxidizer 70 fuel 69er.
Okay, on the left, on the oxidizer 100, on the fuel 101. CCL 212. And on the right, oxidizer 100, on the fuel 100.
Good read back.
Okay, thank you. Go ahead, ECL.
Yeah, this is ECL. Just to let you know, cracks and mass alarm may occur. We're getting ready to pull the probe and put that cap on.
Okay, flight crew, be advised you may get a klaxon here during the cabin leak checks.
Roger.
NTD flight.
OTC, CVFS.
Go ahead, VFS.
Yes, T-minus 20 minute dump is complete, step 909.
Okay, we copy.
NTD flight.
TVD, OTC.
This is TVD.
Right, we're ready for step 917.
That's what I was trying to get with you earlier.
Okay.
What I wanted to do is, with the delay in closing the crew hatch, we want to work that about 10 minutes before coming out of the 9-minute hold.
This is Shuttle Launch Control at T-minus 9 minutes and holding. At the present time, Astronaut Office Chief Dan Brandenstein taking off in the shuttle training aircraft to fly approaches to the runway and to take a look at the weather here in the Kennedy Space Center area. As far as we know at this point, the weather here is not a problem. And we have received back the results from the 8 o'clock balloon run, and it shows that we're very close to having the proper margins in order to launch this morning or this afternoon. The people who do loads analysis are in the process of taking a look at those winds and running through their computer programs to determine whether we can launch today. But in the meantime, we're continuing on with the process here. We completed the dump of the general purpose computer, and now the comparing of that with the programs in the computers here on the ground is in process. In the meantime, back at the Johnson Space Center, everything is in readiness there, and we switch to them for an update.
And this is Mission Control Houston. The Ascent Flight Control Team with the Flight Director Gary Cohen and Capcom John Creighton have been in the Mission Control Center for several hours, monitoring systems on board the Space Shuttle Discovery and keeping an eye on the weather at the transatlantic abort sites and at Edwards. Voice checks between the crew and Houston have been conducted. All positions in the flight control room appear to be go at this time. This is Mission Control Houston.
Did you copy NTD?
Go ahead.
Back here at the Kennedy Space Center, we're continuing on. We have not set a new T0 yet, as we're trying to assess exactly how long it's going to take to complete the work before we can pick up the count at the T-minus 9 minute point. We expect to hear that just a short time from now. The countdown clock at T-minus 9 minutes and holding. This is Shuttle Launch Control.
And Launch Director NTD on 212, Airground 1.
Launch Director on Airground 1, go ahead.
Right, are you ready to do an RTLS weather briefing, 231?
Affirmative. If this is a good time for Houston flight, we can do that.
And flight, how say you? Are you ready to do that launch weather briefing? Flight NTD, Airground 1. Flight NTD on Airground 1.
NTD flight on 212.
Yes, sir. You ready to do a RTLS launch weather briefing?
That is correct.
All right, copy that. We'll set up 231.
Stand by.
Okay,
stand
we'll
by.
stand by.
NTD flight on 212.
Go ahead, flight.
Okay, you're asking for the one that normally comes at minus 25.
That's correct.
And that's negative. I don't need that.
Okay, I copy. And Launch Director, copy.
NTD Launch Director.
Right. Flight indicates that the RTLS weather briefing is not required this time.
Okay. Are we going to summarize that at some other time, or does he indicate there's no concerns and that's green or go?
And flight NTD 212.
NTD flight.
Yes, sir. Were you going to do an update later at 9 minutes when the launch weather looks like it has improved? Or that RTLS is a go at this time?
RTLS is currently go if we go on time, NTD. If we delay, I would like to rebrief.
Okay, copy.
Well, NTD, this is Launch Director. Based on our current status out there, we're at a T0 attempt no earlier than what time? About a half hour from now.
Based upon our current catch-up, yeah.
Okay, copy. Well, we're going to go ahead and have the briefing at this time on channel 231 then. NTD OTC.
Go ahead, OTC.
Right. Before you pick that time, could I get a estimate from ECL on the cabin leak checks? Make sure
in fact, that's probably the long pole at this time. And if you would get an estimate for us so that we can then know when we can pick up and count.
Okay, we copy that. CCL OTC. This ECL, crew module pressurization initial 2 PSI leak check is complete. You can proceed with cabin vent redundancy check. Okay, and CDR OTC.
Roger.
Okay, we'd like to have you perform the cabin vent redundancy check at this time.
You're welcome.
NTD flight.
Go ahead, fine.
We'll certainly support the briefing given that we are 30 minutes away from an expected launch.
Okay, I copy.
OTC CDR cabin vent redundancy check is complete with the ISO closed and the vent open. Talkbacks appropriate.
Copy that. Thank you very much.
OTC CPVD.
PVD, go.
That's like next IPR number.
CMQC, next IPR. Okay, and SP copy?
SP copies.
And PVD, can you describe your problem?
Okay. We have a 1 of 2 mandatory LCC violation. This is a GSE measurement. It's a GECP 4301A. Over aft duct pressure. Indicate low. Indicated 30.36 inches of water. As a 1 sample only. Should be greater than 50 inches of water. The page number on that LCC is 3.1-01.
Okay, and what's your recommendation?
This is shuttle launch control at T-minus 9 minutes and holding. While we have not actually set a T0 for liftoff of Discovery, it is approximately a half hours from now at the...
Right. Flight indicates that the RTLS weather briefing is not required this time.
Okay, are we going to summarize that at some other time, or does he indicate there's no concerns and that's green or go?
And flight entity 212.
NTD flight.
Yes, sir. Were you going to do an update later at 9 minutes when the launch weather looks like it has improved? Or that RTLS is a go at this time?
RTLS is currently go if we go on time, NTD. If we delay, I would like to rebrief.
Okay, copy.
Well, NTD, this launch director, based on our current status out there, we're at a T0 attempt no earlier than what time? About a half hour from now.
Based upon our current catch-up, yeah.
Okay, copy. Well, we're going to go ahead and have the briefing at this time on channel 231 then. NTD OTC.
Go ahead, OTC.
Right. Before you pick that time, could I get a estimate from ECL on the cabin leak checks? Make sure
in fact, that's probably the long pole at this time. And if you would get an estimate for us so that we can then know when we can pick up and count.
Okay, we copy that. CCL OTC. This ECL, crew module pressurization initial 2 PSI leak check is complete. You can proceed with cabin vent redundancy check. Okay, and CDR OTC.
Roger.
Okay, we'd like to have you perform the cabin vent redundancy check at this time.
You're welcome.
NTD flight.
Go ahead, fine.
We'll certainly support the briefing given that we are 30 minutes away from an expected launch.
Okay, I copy.
OTC CDR cabin vent redundancy check is complete with the ISOL closed and the vent open. Talkbacks appropriate.
Copy that. Thank you very much.
OTC CPVD.
PVD, go.
That's like next IPR number.
CMQC, next IPR. Okay, and SD copy?
SD copies.
And PVD, can you describe your problem?
Okay. We have a 1 of 2 mandatory LCC violation. This is a GSE measurement. It's a GECP 4301A. Over aft duct pressure. Indicate low. Indicated 30.36 inches of water. As a 1 sample only. Should be greater than 50 inches of water. The page number on that LCC is 3.1-01.
Okay, and what's your recommendation?
This is shuttle launch control at T-minus 9 minutes and holding. While we have not actually set a T0 for liftoff of Discovery, it is approximately a half hours from now at the earliest. NASA Launch Director Bob Seek is going through another weather report from the Air Force weather people, both for the Kennedy Space Center and all of the other sites around the world, including Edwards Air Force Base in case of an abort once around, Space Harbor in New Mexico, and of course Ben Guerir and Marone overseas. Commander Rick Houck has completed the leak checks, the initial leak checks of the cabin, and also the redundant leak checks are underway. Basically, there is two valves which are in series in the cabin vent system, and the initial leak check verifies the integrity of the first valve, and the second verifies the integrity of the second or redundant valve.
At this time, we are reading within our specs.
Okay, I understand it was a one-time job.
The crew has been advised about the abort weather area, the weather in the abort areas, and are in the process of going through the tasks that are necessary to get us to a launch this morning. The primary objective of the STS-26 mission is the launch of a tracking and data relay satellite known as TDRS. The largest telecommunications satellite ever built, TDRS is a tracking station in the sky. It weighs approximately 5,000 pounds and spans 57 feet once its solar panels are unfurled. It has two 16-foot single-access antennas and operates in 3 frequency bands. NASA leases the satellite from Space Communications Company of Maryland, and prime contractor for the satellites and the ground facilities are TRW Space and Technology Group, Redondo Beach, California, and Harris Government Systems Division of Melbourne, Florida. There's one TDRS already in orbit, and 2 TDRS satellites will be able to support up to 23 user spacecraft simultaneously. Another TDRS is scheduled to be launched aboard the Space Shuttle in January of next year. The countdown at T-minus 9 minutes and holding.
Okay, I need to have you open the cabin vent isolation valve.
Wilco? Cabin vent isol is open, and crew would like to breathe up our suits again.
ECL, we concur with that. Okay. And ECL, can you verify 714? Okay. And CDR, can you verify on panel 01 the cabin pressure is decreasing?
MS2 cabin pressure is decreasing. It's now about 16.1. DPEDT is off scale low.
Okay, and ECL, a caution on step 17 if the VPO2 goes below baseline. We'll keep an eye on it. Copy. And CDR OTC, would you give us a report on cabin pressure on panel 01? Or MS1, whoever does.
This is KMS2 OTC, and we're now at about 15.3. Cabin DPDT is still off scale low.
Okay, I copy 15.3. DPDT is off scale low, right?
That's firm.
Copy. ECO on step 728. Go ahead. Okay, we'll take another reading.
And CMQC NTD, comp 232.
Go ahead, VCC.
Okay, we got the white room configured for launch at this time.
Okay, we copy that. ECO, OTC. Yeah, go ahead. Okay, give me a call when you're ready for that cabin pressure.
OTC, CPVD.
Go ahead, PVD.
Yes, can you give us a time hack whenever we get to be about 10 minutes from coming out of the hold so we can...
Yes, we'll do that.
Appreciate that.
Okay. Okay, VCC, you can verify the all drag-on lines have been removed from the trussway.
Oh, that's verified.
And the flight crew rescue locker equipment has been replaced.
That's been verified, yes, sir.
Okay. And the white room is secured.
That's verified.
Okay, need to have you perform clearing the closeout crew from the FSS and position the FSS elevators at pad surface. Level doors, closed position, power switch in the off position, red button depressed. And
Roger, we'll put that in work when I get down there. I'm going off the net.
Okay.
OTC, MS2.
Go ahead, MS2.
Okay, cabin press is now steady at 14.9. DPDT is 0.
Okay, we copy that, ECO. ECO, you want to wait a little bit longer? Or? It's affirmative, we're still venting. Copy that.
This is shuttle launch control at T-minus 9 minutes and holding. Everything continuing to go very well in the preparations for launch of STS-26 this morning. We have not settled on a firm T0 or launch time yet. Waiting for a confirmation that we have completed the basic tasks that need to be done prior to doing that. The redundant leak checks of the cabin have been completed by Commander Rick Hauk, and the pressure in the crew module brought back to its normal pressure. We're planning that the NASA test director or launch director will brief the crew now on what the plan is.
Tentative plan right now is to pick the count clock up at 11:21 local time, Eastern time, for a T0 at 11:30 local, pending weather okay, pending weather go.
That was NASA Test Director Frank Merlito briefing the team on the plan to pick up the count at the 11:21 point with a launch.
30 to 17:30 GMT. There are colas this morning. First cola is 16:13 through 16:19. Second cola is 17:52 through 17:58, and we will not launch during those periods. If a launch cannot be accomplished within the launch window, or if the following times are exceeded, the NTD will call cutoff. And for a lock strain back, that will be 7 minutes. APU runtime, 7 minutes. IMUs have one correction, SDE NTD. The IMU hold time is 150 minutes, 150 minutes. Okay, and if a hold is issued and requested between T-minus 9 minutes and 31 seconds, the count will be resumed upon successful resolution of the go without a survey made of elements. With some special provisions for the IUS team between 5 minutes and, or 9 minutes and 5 minutes. And PLT at T-minus 5 minutes, perform APU start upon command of OTC only.
Roger.
And CDR, the pad egress system is nominal this morning, and the evacuation helipad is helipad 9.
Number 9.
And fire room launch team, disable your phone ringers at this time.
This is Shuttle Launch Control. NASA Test Director Frank Merlino is going through the briefing that he normally gives at the T-minus 20-minute point, in which he briefs the team on the way in which holds may be called and on the various information that they need to know during the final part of the countdown. One of the things which he mentioned was that the window will extend for this morning's launch from 11:30 a.m. To 1:30 p.m. Eastern Daylight Time this afternoon. The COLA, which he referred to, is a collision avoidance time, and we will not launch from 12:13 to 12:19 to avoid any possibility of collision with objects which might be in orbit at the present time. Not only are we concerned with any collision, but also with coming too close to any of the large orbiting objects, such as the Soviet space station Mir.
CCL 212, go ahead, ACL. Yeah, we're approaching our upper limit on the PPO2 sensors. Wonder if we could ask the crew to stop and close their valve.
Wilco.
This is ISL.
Go ahead, ACL. Yeah, this is TBC. Your DFI battery power up would be local 11:15.
Repeat that time, please.
11:15 local.
Yeah.
Go ahead, sir.
Yeah, safety, verify when non-essential personnel have cleared the launch change area.
Copy.
And STM, track the closeout crew.
Copy and work. CHCD, OTC.
CHCD?
Yeah, step 932. I need to have you put that in work.
Okay, I'll put that in work right now.
And CNSE, OTC. OTC is CNSE. Right, let's see, step 930, 931, those are not performed. That's performed. Copy. OTC, ACL 212. Go ahead, ACL. Yeah, for step 727, you can go ahead and record the cabin pressure at this time. We are stable. All right, copy that. CDR, OTC, and panel, our correction. NS2, could we have the cabin pressure, please?
Roger, on 01, we've got DPDT is 0 and cabin press is 14.9.
Okay, we copy DPDT at 0 and cabin pressure 14.9. And, okay, and ECL, do you have the press? Yeah, OTC CCL, we're looking at 14.89. Okay, we copy 89, and we've already done step 729, 730. And you verify 731. That's a negative OTC. I thought we closed the vent valves. We show them still open. CDR OTC.
Roger.
Okay, we need to close the cabin vent valves.
And work. That's complete. Talk back, show close, both valves.
Okay, we copy. OTC CCL, I can verify step 731. Thank you.
And flight NTD 212. Flight NTD on 212, airground 1.
PVD OTC. PVD. Right, would you give us a heads up when you start reduction on the payload bay purge? Copy that.
NTD flight on 212.
All right, RTLS update for step 929.
All right, stand by. We'll do that.
This is Shuttle Launch Control. We're getting further into the countdown now. We're getting up to tasks which occur in and around the T-minus 20-minute build-in hold as we work towards a liftoff this morning at 11:30 a.m. In addition to the major payload on board the orbiter, the TDRS Tracking and Data Relay Satellite, which is owned and operated for NASA by Contel Federal Systems, there is a number of other payloads also on board, located primarily in the middeck. An automated directional solidification furnace, which is designed to conduct material processing experiments in a low G or low gravity environment. An aggregation of red blood cells experiments.
I presume we'll get a update on availability.
An isoelectric focusing experiment, which is a technique for separating compounds by utilizing the differences in their electrical and chemical properties. Another is the protein crystal growth experiment, and the physical vapor transport of organic solids experiment. This is a 3M experiment, which is to obtain thick and highly ordered crystalline films on selected substrates. The countdown continuing on, we're in the process of completing the cabin leak checks and the venting of the cabin pressure into the payload bay. Everything going satisfactory as we look for a liftoff at 11:30 a.m. this morning. This is Shuttle Launch Control.
OEX copy.
All right, no problem. And ITD, NTD, Airground 1.
Go ahead.
Right, do your whole fire system enable per the clock. That'll be a GMT 1515.
Roger, copy.
Okay, all stations, NTD, what I'd like to do at this time is the launch status check. All stations that can respond, I'd like them to do so. OTC?
This is the OTC. We have one operation that's still in work at this time. That's reduction of the payload bay purge. As soon as that's complete, the orbiter will be go.
I copy. And TBC?
Tank booster go.
PTC?
We're ready.
LPS?
LPS is go.
Flight? Mila?
Milo's go.
STM?
STM is go.
Safety console?
Safety's go.
SPE?
Okay, NTD, we do have one item that we would like to bring to your attention. On CPO2 sensor A, we're very close to the LCC upper limit. Because of the cabin pressure checks that have been done, we're now conferring with the design center to ensure that if we increase above the LCC limit after the time period of activity of 9 minutes, that it will not be a problem. So stand by on SPE's call.
Okay, copy. And CDR and PLT?
Roger, CDRs go.
PLT's go.
LRD?
LRD's go.
And safety console is the closeout crew at A11?
Affirm.
Okay, does that mean KSC area is clear for launch?
Affirmative.
Okay, and SRO NTD?
SRO, I copy, and I can give you a goal based on that.
Thank you.
This is Shuttle Launch Control. NASA Test Director Frank Merlino has just run through a status check of the primary test conductors and crew to determine whether we are ready to proceed with the launch. And we have had an affirmative answer from everyone. At this point, Bob Crippen, who is Deputy Director of the National Space Transportation Program for NASA, is conducting a poll of the mission management team. This is a procedure that became more formalized since the Challenger accident to ensure that no major manager has any hesitancy about proceeding with the launch. He is asking each of the element managers, NASA Orbiter, Rockwell Orbiter, NASA main engines, etc., to verify that they are sure that we should continue on, and he will report his findings to the launch director.
NTD, PTC.
Go ahead.
Can we verify the count will resume at the planned T-minus 9-minute point?
That's right. We, at this point in time, unless we get scrubbed or delayed, we'll come out at 11:21 local time, 15:21 GMT. Thank you.
OTC, CPV.
Go ahead, PVD. PVD.
This is Shuttle Launch Control. We're standing by now for Bob Seek, who is the Deputy Director of NSTS Program for Operations for NASA, to report to the Launch Director, and then we'll hear that we are ready to pick up the count.
NTD STE 212.
Go ahead.
Yes, sir. Can I ask Flight a question?
Sure.
Flight to STE 212.
NTD OTC.
Go ahead.
Okay, our payload bay purge flow rate is complete at this time, and the orbiter is go.
I copy.
NTD flight on 212.
Go ahead, Flight.
I have a short, brief weather status for the crew when we can work it in here.
Okay, now's a good time.
Capcom, go ahead.
Discover Houston.
Go ahead.
Okay, I've got your TAL weather for you. Prime TAL is Maroon. The weather is clear and 7+. Altimeter 293. And your winds at Maroon 250, 10 gusting to 15. That's a breakdown of 7 knots of gusting to 11 knots of headwind, 7 gusting to 10 knots of right crosswind. Ben Guerir is currently 10,000 broken, 22,000 broken in 7. It's no-go for winds. The winds are currently 070, 15, gusting to 20. They also have Virga within 15 miles of the field. Banjul, currently 1,200 scattered, 1,800 scattered, 13,000 scattered in 7. Winds 050 at 6. And they have CBs northwest to northeast of the field. Both Ben Guerir and Banjul are available as a contingency site.
Okay, appreciate the update.
Okay, all stations, be advised the clock will pick up in about 3 minutes, 20 seconds.
Okay, NTD Flight, STE Air to Ground 1.
NTD flight.
Okay, Flight, this is STE. We have a question for ECOM.
Go ahead.
Okay, ECOM, we're very close on the upper limit on CPO2 sensor A. The LCC limit is 3.3. We're currently reading 3.26. And we're looking for confirmation that after we pick up the clock at 9 minutes that an increase above this level, upper limit is not a concern.
ISL OTC.
STC flight. NTD flight.
Go ahead, Flight.
You have concurrence from ECOM.
Okay, and
And from flight.
STE copies, and one other thing, NTD, because of the concern of the increase in cabin pressure with the new suits, we could potentially get a master alarm, which would cause us to hold as we count down. And with that, we'll status the condition at that time and give you a go.
Okay, I copy. And GLS NTD.
Let's go.
Right, we may cancel pending at this time, and what we'll do, we'll go ahead and work the remainder of the steps in an orderly manner and then give you a go.
I copy.
Okay, and NTD STE.
Go ahead, ST.
STE's go.
I copy. Thank you. And Launch Director NTD.
This Launch Director, go ahead.
Right, Launch Team ready to proceed.
Okay, copy. Have you given the go to payload to go internal?
Have not PTC NTD.
Go ahead, NTD.
Right, at this point in time, knowing that we will be picking up momentarily, we would like you to go ahead and pick up your activities.
No, you missed the count clock at 3 minutes and 2 minutes like we're supposed to get.
Right, I understand that. So we'll give you a 3-minute count out once we establish all the communication and all the coordination.
I copy.
Okay, copy.
NTD SRO on 212.
Go SRO.
A final clear to launch from the range.
I copy, SRO.
Okay, currently in brake field, it's a skip on 133. Okay, the unit? NTD, PTC. Go ahead. Okay, we're ready. You're ready for, okay, stand by, if you would, payloads, and launch director. What I'd like to recommend is that as soon as we get the status checks complete, we give the team a 3-minute count out to 9-minute counting.
I copy. Okay, let me finish the final poll here. Payload operations management.
Launch director, ops manager on 212. If you're calling me, all of the mission management team is go to proceed with launch.
Copy. Thank you, sir. Engineering director.
Engineering, launch director, this is engineering director. I have pulled the technical community, and you will have our consensus to proceed with this launch. Good luck and Godspeed.
Copy. KSC safety and quality director.
Safety and quality has no constraints to launch, Bob.
I copy. Payload operations management. Payload operations management has no constraints to launch, Bob. I copy. Cape Weather launch director. Cape Weather has no constraints. I copy.
Okay, TD, launch director, true, we could not.
Go PTC. Okay, IUS went ahead and has finished their final launch configuration. Okay, I copy. Nonetheless, we'll establish a new time and then come out of this count upon that time. And launch director, excuse the interrupt, proceed.
Okay, well that's what we did, and we can. Somebody was breaking in. Go ahead.
Yeah, this is a CDR. We could not hear weather's report.
CDR, we copy. We need a repeat on weather.
Yeah, he's down in the mud.
Cape Weather launch director, you want to summarize the current op again, please, sir? Roger, sir. Stand by. Cape Weather, you're very weak. Can you try another comm? Well, you're very weak, but readable. Discovery, can you copy Cape Weather?
Negative. Would you just relay his report, please?
Okay, Rick. Well, what we've got in the local area is winds are northeasterly, and they're less than 10 knots. Current weather conditions, we got some scattered low stuff below 5,000. We got some showers offshore that are topping out around 14,000. None of that is within 10 miles.
Okay, thanks very much.
Go ahead, Cape Weather. Roger, sir. We have some small showers. I copy, and they're moving to the west. Okay, and you're still go, Cape Weather.
ITD 212.
Go ITD.
Sequence 16973, hold 5 system is enabled.
I copy it. Payloads, are you ready for count resumption? We're ready for count resumption now. We need an AT0. Okay, copy.
Okay, this launch director, why don't you set that for, we come out of the hold in approximately 3 minutes.
I copy, and TLS, NTD. Would you set the clock to come out at 15:28 GMT? I copy. And about 3 minutes, 10 seconds for thereabouts.
This is Shuttle Launch Control. We have just heard Launch Director Bob Seek receive a go from all elements of the launch team, including Bob Crippen, who is the Deputy Director of the National Space Transportation System and the head of the Mission Management Team. We'll be picking up the countdown clock at 11:28 at the T-minus 9-minute point, which would give us a liftoff time at 11:37 Eastern Daylight Time this morning. During this period, recorders which document the operation of the final minutes of the countdown and the flight recorders have been turned on. Just 1 minute before the countdown resumes, the Oasis payload in the orbiter bay will be activated to report its findings at the high bit rate. The OASIS instrumentation is designed to determine the environment of the payload bay, such as the effects of temperature, pressure, vibration, and will be used for the design of future payloads in upper stages.
We'd like you to consider us closing our visors a little bit later in the count, just to lessen the probability of getting that TPO2 alarm.
Okay, we copy. Do you have a recommended time?
2 minutes.
2 minutes? We copy.
That's firm. 2 minutes.
We copy.
A minute and a half away from picking up the countdown. We've just had a request from the crew that they close their visors a little later in the count at the T-minus 2 minute point.
CLEX OTC. Did you get a recorder start?
Negative, we don't have a recorder activation yet.
Is that a problem, or is it just...
I'm talking to, I'm trying to get in touch with Houston Flight to find out when they anticipate sending that command.
Less than 1 minute away from resuming the count for the launch of STS-26, looking for a liftoff at 11:37 a.m. this morning.
Bill?
Okay, Rick, well, we're all set down here. We got about 9 minutes of work left to get this program back into space. We'll keep a close eye on things during that time, and we'll be with you all the way.
Thank you, Bob. We're sure looking forward to it.
Launch Director Bob Seek giving a message to the crew and an answer from Commander Rick Hauk. The clock will resume in just 5 seconds from now. 3, 2, 1, T-minus 9 minutes and counting. The countdown events are now being controlled by the ground launch sequencer from now until the T-minus 31 second point, when we begin the switch over to the onboard redundant set launch sequencer. The ground launch sequencer is part of the launch processing system and operates by relaying commands to the onboard computers, which then report back to the LPS system that the commands have been executed. 8 minutes 30 seconds and counting. The primary job of the onboard computers is to check that all of the launch commit criteria, such as propellant loads, temperatures, pressures, and other measurements, are normal and staying within their prescribed limits.
And Flight OTC, I'd like to have you proceed with the transmission of the stored program commands.
Coming up the 8 minute point, T-minus 8 minutes and counting.
Flight OTC.
The Orbiter Test Director has requested that Houston send the stored program command, which is the final update on antenna management and frequency changes. This ensures that the orbiter has the latest information to speak to various ground tracking stations as it circles the Earth.
Roger. Flight, proceed with transmission of the stored program commands.
T-minus 7 minutes, 30 seconds and counting, and the ground launch sequencer has started retracting the orbiter crew access arm. This is the walkway used by the astronauts to enter the orbiter. In case of an emergency, the arm can be placed back into position within about 15 seconds.
Okay, we copy.
T-minus 7 minutes and counting. The orbiter access arm moving away from the orbiter now into its park position. T-minus 6 minutes, 30 seconds and counting. Pilot Dick Covey will be asked to set the switches in the cockpit to the pre-start position for the auxiliary power units, or APUs, at the 6 minute point. This consists of positioning a number of switches and verifying that they're in the proper position, then throwing the 3 propellant isolation valve switches, which allow the hydrazine to start flowing towards the APUs.
I'd like to have you perform the APU pre-start. APU pre-start's in work.
We've passed the 6-minute point, T-minus 5 minutes, 54 seconds and counting.
OTC, PLT, APU pre-start complete, 3 gray talk bench. Copy.
T-minus 5 minutes, 30 seconds and counting. Mission Control has transmitted the signal to start the onboard flight recorders. The 2 recorders will collect measurements of shuttle systems during flight and be played back afterwards. At the 5-minute point, the orbiter test conductor will ask pilot Dick Covey to start the auxiliary power units, which provide hydraulic power for steering and controlling flight surfaces. T-minus 5 minutes and counting.
Let's go for orbiter APU start. And PLT, perform the APU pre-start. Roger, and work.
Pilot Dick Covey now is flipping the 3 switches in the cockpit to start each of the 3 APUs. The liquid oxygen replenishing of the LOX tank has been terminated at this point, and the liquid oxygen fill and drain valve is closed. 4 minutes, 30 seconds.
See, the APUs are up and running. Copy that.
The auxiliary power units up and running according to pilot Dick Covey.
CDR, reconfigure heaters.
Roger, that's complete.
Coming up on the 4-minute point in the count. The crew would normally close their visors, but will delay that. The main engine final purge sequence is underway. The orbiter flight control surfaces, such as elevons, speed brakes, and rudders, are now being moved through a pre-programmed pattern to verify that they're ready for launch. T-minus 3 minutes, 30 seconds. All 3 engines now being moved in a pattern to verify their readiness to support the ascent flight control. After going through their paces, they'll be aligned to their start positions. We're coming up on the 3-minute point in the count. At T-minus 2 minutes, 55 seconds, the start of the external tank liquid oxygen pressurization will begin. 3 minutes and counting. And the gaseous nitrogen purges of the main engines will be terminated.
Go for ET-LO2 pressurization.
The ground launch sequencer has started to retract the gaseous oxygen vent hood or beanie cap on the external tank.
I'd like to have you clear caution warning memory and verify no unexpected errors.
The computers will make a final check to ensure the vent arm is fully retracted at the 37-second point. T-minus 2 minutes, 30 seconds and counting. Ground supplies of hydrogen and oxygen for the orbiter fuel cells has been turned off. Discovery is now running on its onboard reactants. Coming up on the 2-minute point in our countdown. T-minus 2 minutes and counting. Liquid hydrogen replenish of the external tank has stopped, and pressurization to flight level is underway. The vehicle is now isolated from all ground propellant and fluid loading equipment.
Roger, that's complete.
CLS go for ET-LH2 pressurization.
T-minus 90 seconds and counting. Less than 2 minutes away from the launch of STS-26 and its crew of 5. And we have heard that the clock will hold at 31 seconds.
In PDST, it's a cabin pressure rated change. Okay, copy. DCL.
We're anticipating the clock will hold at T-minus 31 seconds due to a failure. We have not heard what that is yet.
It's going down. Probably due to the increase in the O2 going in from the suits. Okay, and with your concurrence, we'll clear the air and proceed.
T-minus 50 seconds and counting. We're going to clear the air and proceed. Had a concurrence from the launch director to proceed.
And if we clear, we will not stop at 31. Is that true?
That's correct, NTD.
We will not stop the clock. The orbiter computers have positioned the vent doors. T-minus 31 seconds. We have a go for auto-sequence start. Discovery's 4 redundant computers have assumed. T-minus 23 seconds and counting. The SRB nozzle profile T-minus 15, 14, 13, 12, 11, 10. We'll go for main engine start. 7, 6. We have main engine start. 3, 2, 1, 0, and liftoff. Liftoff. Americans return to space as Discovery clears the tower.
Program.
Roger, roll, Discovery.
Crew confirms roll program. Houston now controlling. 3 engines at 104%. 3 good APUs, 3 good fuel cells. Standing by to begin throttle down to 65%. Engines throttling down now to maintain a certain speed as the spacecraft passes through max Q. 3 engines at 65% now. Standing by to see engines begin to throttle back up at about 59 seconds. Mark 1 minute, velocity 2,300 feet per second, altitude 5.9 nautical miles, downrange distance 3 nautical miles.
Discovery, go at throttle up.
Roger, go.
Discovery given a go at throttle up, 3 engines at 104%, velocity 3,200 feet per second, altitude 10.8 nautical miles, downrange distance 8 nautical miles. About 25 seconds from solid rocket booster separation. 1 minute 45 seconds, 3 engines at 104%. Velocity 4,800 feet per second, altitude 20 nautical miles, downrange distance 19 nautical miles. Standing by for solid rocket booster separation. Solid rocket boosters have separated. 2 minutes 20 seconds. 3 engines still running 104%. 5,600 feet per second velocity, 31.8 nautical miles. Altitude, downrange distance 38 nautical miles. 3 APUs still running at normal speed. 3 good fuel cells. We'll be hearing some call-ups here shortly from the Capcom about the capability to reach transatlantic sites. Velocity 6,200 feet per second, altitude 41 nautical miles, downrange distance 60 nautical miles.
Discovery, 2-engine, Marone.
Roger.
That call-up indicating Discovery may be able to achieve a transatlantic abort at Marone if that were to become necessary. Return status and mission control positions all report go. 3 engines still 104%, velocity 7,600 feet per second, altitude 53 nautical miles, downrange distance 107 nautical miles. Standing by for negative return.
Discovery, negative return.
Negative return.
That call-up indicates Discovery now can no longer turn around and return to the launch site in the event of an abort. 4 minutes 20 seconds, velocity 8,700 feet per second, altitude 59 nautical miles, downrange distance 148 nautical miles. Standing by for press to ATO call.
Discovery, press to ATO, select Banjul.
Select.
Call-up indicates Discovery could reach an abort to orbit on 2 engines if that were to become necessary. 5 minutes 3 seconds, velocity 10,300 feet per second, altitude 65.7 nautical miles, downrange distance 203 nautical miles. Standing by for a press to MECO call.
Discovery, press to MECO, group Banjul 109.
Roger.
Crew given their press to main engine cutoff call, indicating they can proceed to normal main engine cutoff on 2 engines if that were to become necessary.
Discovery, performance nominal.
Roger, nominal.
6 minutes 10 seconds, velocity 13,900 feet per second, altitude 68 nautical miles, downrange distance 323 nautical miles.
Discovery, single engine Banjul 104.
Roger.
That call-up indicates Discovery could achieve a single-engine landing at Banjul if that were to become necessary. Banjul, one of the transatlantic abort sites. 6 minutes 50 seconds, velocity 16,400 feet per second, altitude 66 nautical miles, downrange distance 405 nautical miles. Guidance officer reports good navigation aids, and main engine cutoff is expected at 8:33.
Discovery, single engine press, 104.
Roger.
Discovery's crew told that they can press on to main engine cutoff in the event of a 2-engine failure. 3 engines running at 104%, 3 good APUs, 3 good fuel cells, velocity 20,000 feet per second, altitude 61 nautical miles, downrange distance 527 nautical miles. Engines beginning to throttle now to maintain 3 Gs. Mark 8 minutes, velocity 22,500 feet per second, altitude 59 nautical miles, downrange distance 619 nautical miles. At about 82% throttles now, maintaining 3 Gs on the vehicle. 10 seconds away from main engine cutoff. Velocity 24,600 feet per second. Altitude 59 nautical miles, downrange distance 700 nautical miles. Standing by for main engine cutoff. Main engine cutoff confirmed. Discovery's 3 main engines have now shut down as programmed.
Discovery, nominal MECO, ohms 1 not required.
Normal main engine cutoff has occurred now.
Okay, thank you, Houston.
Crew informed that ohms 1 is not required. There'll be an ohms 2 to round out the orbit at the expected altitude. Standing by for external tank separation.
Discovery, your go for APU shutdown on time.
Roger.
APUs provide hydraulic power to operate the aerodynamic services and to gimbal the engines. Booster Systems engineer reports that the excess propellants remaining in the lines are being dumped out through the main engines as scheduled at this time.
And Discovery Houston, we're with you through TDRS.
Okay, loud and clear. We just got a PPO2 alarm, 3.6.
Copy, PPO2 3.6.
And we found one manifold, O2 manifold open that probably caused it. We got them all closed now.
We copy that, Rick.
That exchange with the ground and the crew talking about an oxygen pressure difference beyond what was expected. The crew noticed an open manifold and has closed that, and they expect that solves the problem. Space Shuttle Discovery still on its way to orbit after a successful ascent up through main engine cutoff. We still will be requiring an ohms 2 burn, and that will circularize the orbit at approximately 160 nautical miles. That burn occurs at about 30 minutes into the flight. We're now communicating with the crew of Discovery through the tracking data relay satellite. Ascent for the Space Shuttle Discovery this morning. Booster Systems Officer reports the main propulsion system purge has been complete. And we're about 26 minutes away from the start of the ohms 2 ignition. The orbital maneuvering system engines will be fired to circularize Discovery's orbit at approximately 160 nautical miles.
Discovery Houston?
Roger.
ohms 2 targets nominal, on time, Delta V, total 223.
Okay, thanks.
That call up from J.O. Creighton, the Capcom, to the crew that they will proceed with the nominal planned ohms 2 burn with all the parameters just as planned pre-mission. Change in velocity, adding 223 feet per second to the velocity of the spacecraft, putting it in a approximately circular orbit.
Go ahead, Discovery.
Roger, J.O., right at liftoff, we got a fuel cell pH indication for fuel cell 2. It appeared to be a transient. We took no action. I just want to make sure you concur with that.
We concur with that. We also saw it.
Roger.
The orbital maneuvering system burn coming up in about 23.5 minutes.
Discovery Houston?
Roger.
We'd like to verify that H2, Tank 2, Heater Bravo is in the auto position.
H2, Tank 2, Heater Bravo. Okay, it was in the auto position, but tank 1 Bravo was not. It is now in auto.
Copy. Tank 1 was not, but it is now.
That's affirmative.
This is Mission Control, 18 minutes and 10 seconds mission elapsed time. The Space Shuttle Discovery's crew maneuvering the spacecraft to the burn attitude for that final push into orbit, adding 223 feet per second to the forward velocity of the spacecraft. The crew reported a transient reading in the pH of fuel cell 2 at liftoff and wanted to clarify that that was not a problem, and Mission Control concurred. A very smooth ascent this morning for Space Shuttle Discovery. The crew has loaded the OMS burn targets into the onboard computers, and we're 21 minutes away from the start of that OMS burn. This is Mission Control.
Houston, Discovery?
Go ahead, Discovery.
Roger. On spec 0, we just have a high load of VAP down arrow.
Copy.
Correction on the thermal display.
Discovery Houston, we'd like you to take the high-load duct heaters to Bravo.
Okay, that's complete.
This is Mission Control Houston at 26 minutes and 27 seconds mission elapsed time. We're about 13 and a half minutes away from the start of the OMS 2 burn, which will be the final push into orbit for Discovery and its crew. The Discovery is right now out over the eastern portion of the Atlantic, just off the coast of Africa, about to cross the equator on the downward leg of its orbital ground track. And we expect to be able to get data on the process of the OMS burn as it occurs, because we will still be within range of the tracking data relay satellite. The auxiliary power units on board Discovery have been shut down now. Those provide hydraulic power during ascent and entry. During ascent, they're primarily operating the gimbals of the main engines. And during entry, the hydraulics are operating the aerodynamic surfaces.
Discovery Houston.
Roger.
Rick, we'd like you to take the high-load and topping evap heaters to the A/B position.
Okay, that's complete.
This is Mission Control Houston. It's 36 minutes into the discovery of into the flight of Discovery, STS-26. Spacecraft is now over the southern portion of Africa. We'll be crossing over Madagascar here very soon. And we're 3 minutes and 40 seconds away from the start of the OMS 2 burn. That will be the final push into orbit and to add 223 feet per second to Discovery's forward speed. Systems officer just reporting to the flight director that the vacuum inerting process, part of the process of safing the main propulsion system, has been completed. Discovery's APUs have been shut down, and this OMS burn, coming up in a little less than 3 minutes, will put Discovery into an orbit of approximately 160 nautical miles circular. We have about 5.5 minutes remaining of TDRS coverage here before we go out of range, and the next site we pick up through will be Yargity, Australia, for UHF comm, and we're 2 minutes away from the OMS 2 burn. Since Discovery will be within range of the tracking data relay satellite at the time the burn begins, the propulsion system officer and the guidance officers will be able to observe the conduct of at least the first portion of the burn. Flight Director Gary Cohen now polling the operators in the room who are concerned with the process of the OMS 2 burn, and all of them report that they are go. Propulsion's officer reports to the flight director the burn is in progress and it looks good. Thrust vector control on the OMS engines looks good.
Discovery Houston, 20 seconds to LOS TDRS. We'll pick you up at Yargety in 9 minutes.
Roger, it's nice to be in orbit.
And Space Shuttle Discovery is now in orbit. The Ohms burn complete. Propulsion system officer reported that the burn looked good. Passing out of range of the tracking data relay satellite now, and as Capcom John Creighton says, we'll pick them up in about 9 minutes through the Yargety UHF station in Australia. This is Mission Control. This is Mission Control Houston at 51 minutes mission elapsed time. We're about 30 seconds away from picking up communication with Discovery again through the Yargety station.
Discovery Houston, with you through Yargety. How do you read?
Okay.
Loud and clear, Howie.
Okay, we got you loud and clear now.
Okay, J.O., we've had a vap out temp out of limits a couple times. We've cycled the CES both through CES A and CES B. It just isn't quite hanging it. Gets down to about 39, 38 degrees, and then it'll...
Okay, Rick, we believe there's some moisture in the high-load duct, and looks like the duct heater is just not hacking it. Topping a VAP is working okay, and we're working on a plan to come back to you and try and resolve the issue.
Okay. Cycling the CES to restart it each time it goes into limits.
We copy that. And Discovery, Houston?
Go ahead.
We'd like you to go secondary on and high load off.
Okay.
This is Mission Control, a discussion with the crew and the Capcom about the flash evaporator system, part of the cooling system on board the orbiter that is used largely before the doors are open, but also otherwise in the flight. The crew reporting in the ground also having noticed a significant drop in temperature in a portion of that, and the crew just given a configuration change to help overcome that temperature drop problem. Commander Rick Houck reporting that they just periodically...
And Discovery, Houston?
Periodically cycled the FES when they saw that temperature drop.
Discovery, Houston, over.
Go ahead.
Raj, could you give us a status of your gimbal checks?
Okay, we did a gimbal check, and we failed the secondary. The left secondary failed. It didn't look like it moved at all.
Copy, left secondary failed, and I assume everything else was okay.
That's affirmative. And right now, Houston, it looks like we're controlling on the secondary FES on the topper.
Okay, we copy that. Thanks.
Houston, Discovery.
Go ahead, Discovery.
Roger, copy. Looks like we're controlling on the secondary topper at 60 degrees.
Roger, we copy that. Controlling on the secondary at 60.
This is Mission Control, the crew reporting that they had switched to the secondary flash evaporator system, and it was controlling at about 60 degrees, apparently overcoming the difficulty they had with the primary flash evaporator system. And they also reported down that they had completed their gimbal check of the Ohms engines, which is a procedure done after an Ohms burn to test the functioning of the mechanisms which tilt the nozzles, which change the direction of thrust of those engines during firing. And the report from the crew was that all of those passed with the exception of the left Ohms secondary. There are primary and secondary systems in those gimbaling mechanisms, and he reported that the left secondary had failed, but the other ones were good. We still have about 3 minutes remaining in this pass over Yargety. This is Mission Control.
And Discovery, Houston, I've got a flight note for you concerning the post-insertion checklist when you get ready. Okay, on page 1-13 in the post-insertion checklist. And Discovery, if you tell me when you got it open to that page.
Houston, we didn't copy. We thought we'd lost you. What was the again the page?
Page 1-13.
Standby. Go ahead.
Okay, middle of the page where it says clear the star table, item 20. We need to move that up to a time. Okay, we need to, at the middle of that page where it says clear star table at 2 hours and 15 minutes, we need to move that up to a time of 2 hours and 9 minutes. Over.
Okay, we'll move the clear star table from 2:15 to 2:09.
That's a good copy. We're LOS Yargity in 30 seconds. We'll pick you up at Hawaii in 18 minutes.
See you there.
This is Mission Control Houston at 1 hour mission elapsed time. We have loss of communication with Discovery through the Yargity station. We'll be picking up again in 17.5 minutes through Hawaii. Just to summarize, since launch this morning, the Discovery went through a normal launch, a direct insertion. Things went very well, very smoothly during launch. The three main engines appeared to operate perfectly up to main engine cutoff at slightly over 8.5 minutes. And that was followed by external tank separation and the OHMS 2 burn, which was completed just a short while ago. And that OHMS 2 burn added the final push of forward speed necessary to place Discovery into orbit. And that occurred just out over the south part of the Indian Ocean, was completed just before we lost the communication through the tracking data relay satellite. However, the crew reported through the Yargity station that in going through their checkouts of the mechanisms which move the nozzles of the OHMS engine around, that the secondary system of the left OHMS engine was not operating properly. There are primary and secondary mechanisms for moving the OHMS nozzles to direct the thrust of those engines. The crew was also working an apparent problem with the flash evaporator system, in which they saw some low temperatures operating in the primary side of the flash evaporator system. They switched over to controlling with the secondary portion of the flash evaporator system, and that appears to be operating normally at this time. The flash evaporator system helps cool the orbiter and all of its electronics, primarily during that period of time when the orbiter's doors are closed, before the doors have been opened up and the radiators can be deployed. Launch occurred at 10:37 Central Time this morning. And the Space Shuttle Discovery is now in orbit of approximately 160 nautical miles circular. We'll be picking up communication again through Hawaii. The spacecraft will be crossing over the equator on the upward leg of its ground track out over the Pacific. Just now at the northeast portion of the Australian continent. And we're 14 minutes away from acquiring communication through Hawaii. This is Mission Control Houston. And this is Mission Control Houston at 1 hour and 6 minutes into the flight. For those who have been asking, the flowers on the flight director console are in front of the flight director console here in Mission Control were given by the security organization here at Johnson Space Center, just as as an expression of their good wishes and hope that the flight would go well to the Mission Control team. This is Mission Control. This is Mission Control. We're standing by for acquisition through the Hawaii station.
Discovery Houston, with you through Hawaii.
You're loud and clear, Houston.
Roger, we hear you, Discovery.
This is Mission Control and Flight Director Gary Cohen polling the operators in the room for a go, no-go decision or go for payload bay door operations.
Houston, Discovery.
Go ahead, Discovery.
Roger, we have not accomplished on page 1-8 block 4 due to our test config, so that has not been accomplished. Also, the AME data take at 106 we did not complete in that we were late going to payload bay door opening attitude, and so we will get the first AME data take after this attitude. Now, Matthew will want us to take another one to satisfy that requirement.
Okay, we copy that. And Rick, you have a go for payload bay door opening when you get to attitude.
Okay.
Discovery Houston.
Roger.
On that post-insertion, page 1-8, block 4, we would like you to perform block 4. Over.
Say it again.
Rick, we would like you to do the radiator activation block 4 on page 1-8. Over.
Okay, you cut out. I think you said go ahead and do the block 4, which makes sense, even though we don't have the evap out temps indicated.
That's affirmative, Rick. And Discovery Houston, I have a flight note for you concerning the cap on page 3-2 when you're ready.
We don't have those out yet. If that's not critical, we'd like to prefer that.
Okay, we'll pass it up later.
Okay.
And Discovery, we're 1 minute to Hawaii LOS. We'll pick you up shortly with TDRS.
Roger.
Discovery Houston, we're with you through TDRS.
Loud and clear, and door sequence is in progress, as you can see. Also, first AME data take was at 1:22:35.
Copy, doors in work, and the first data take was at 1:22:35.
Houston, Discovery.
Go ahead, Discovery.
Okay, payload bays are open, no anomalies, dual motor times on all operations.
We copy that, thanks.
Payload bay very clean, just a little bit of tape and dust and other crud floating out of it.
Okay, we hear that.
And for the folks at the Cape, the cabin is as clean as I have ever seen. I think we found one screw.
Okay, I'm sure they'll be happy to hear that.
Houston, Discovery.
Go ahead, Discovery.
Okay, J.O., we're passing over the Cape again, and just want to give our heartfelt thanks to all those folks down there who did all this good work.
I'm sure they're all happy to hear that. I know they spent a lot of, long hours getting you ready, and we're all really happy to see that it went off without a hitch, and we're wishing you good luck over the next 4 days.
Thanks, and we're still smiling.
I'll bet you are. Discovery Houston.
Go ahead, Houston.
Raj, you've got to go for orbit ops. And I've got a couple of notes when you're ready to copy.
Okay, we'll take these suits off. Thank you.
Word you've been waiting to hear for about 4 hours.
Raj.
Discovery Houston.
Go, Houston.
Okay, I've got a couple words for you on some switches. First off, on panel A14, we would like you to take the forward RCS heater A to auto. Okay, understand complete. And on page 1-13 in the post insertion, block 14, for resetting caution and warning. If you haven't already, do not reset the cabin press limits because you're already above that limit. If you lower the limit, and you'll trip an alarm.
Okay, we won't change the cabin press limits on Block 14.
And one last note, when you get to the switch reconfiguration on the pictorials, leave the duct heaters to on.
Okay, duct heaters to be left on. We'll do that.
That's it.
Houston Discovery, 30 seconds to actuator operation.
We copy that.
Houston Discovery, the primary actuator is engaged. Nominal time.
We copy that. Thanks.
Houston Discovery.
Go ahead, Discovery.
Second AMU data take, 1 hour, 47 minutes and 5 seconds.
Copy 1:47:05. And could you give us the results on your Star Tracker self-test?
Roger, we had a pass on both of them and the doors opened on double motor time.
Okay, thanks a lot. Discovery Houston, you have a go for vernier ops.
Try to go for verniers.
Discovery Houston, I've got a couple of flight notes for you when you're ready.
Go ahead.
Okay, Rick, on the post insertion at 2 hours and 10 minutes, that's page 1-13, we would like to insert a Tank 3 cryo heater check. So on panel R1, we'd like the O2 and H2 Tank 3 heaters, A and B, to auto. Over.
Okay, at 2 plus 10, R1, O2, H2, Tank 3 heaters, A and B, that's 4 switches to auto.
That's good copy. And another note, when the Freon loop rad out temp gets below 60 degrees Fahrenheit, we'd like you to, on L1, take the flash evap controller secondary to off and take the radiator out temp to high. And this is in an attempt to try and get rid of some of the ice in the ducts.
Okay. When it gets less than 60, press secondary off and right out to high.
That's a good copy. Discovery Houston, with another flight note for you when you're ready.
Go ahead.
Rick, does anybody have a cap out yet?
Not yet. We'll go get one.
Well, I can give it to you, verbally, and then you can pencil it in the cap when you get one out. Okay, the note has to do with the stars that you're going to use for your star line. And the two stars are star 48 in the minus Y tracker and star 28 in the minus Z. I'm corrected here. They're both minus Y stars, 48 and 28. The angular difference, 91.7. The stars will both be in the table at 2 hours and 40 minutes. However, the first star will be available at 2 hours and 15 minutes. Over.
Okay, understand. Stars 48, 28, minus Y, both of them, Delta Ang, 91.7. 48 will be available 2 plus 15. They'll both be available 2 plus 40.
That's a good copy, and the attitude for those stars will be the same attitude that's in your post-insertion checklist, page 1-9, and that's your payload bay door attitude.
Okay, current attitude.
That's affirmative.
Okay, JL.
This is Mission Control Houston at 2 days, 7 hours mission elapsed time. The Discovery is on orbit number 2, just crossing over the western coast of Africa from the Atlantic Ocean. The crew is busily going through their post-ascent, post-insertion timeline, configuring the spacecraft for orbit operations. They were given a go for orbit operations at 1 hour 41 minutes mission elapsed time. Previously at 1 hour and 30 minutes mission elapsed time, the crew reported that both doors were fully open and that there were no anomalies, dual motor times on all operations, which indicates that all the electric motors which operate the doors in their deployment sequence were functioning properly. I believe it was Pinky Nelson reported that the payload bay was very clean, and also that the interior of the spacecraft in the crew cabin area was very clean, the cleanest he'd ever seen it. As the Discovery passed over the Kennedy Space Center area about a half an hour ago, the crew offered their thanks to the people there at Kennedy Space Center who did the work to get them in orbit this morning in preparation of the vehicle there at the launch pad. And at 1:41 mission elapsed time, when the crew was given a go for orbit operations, the commander, Rick Houck, apparently a jubilant expression said the crew was very glad to get the suits off. Just to review some of the activities so far this morning, we had a normal ascent, a direct insertion. Everything appeared to be operating pretty normally, and we had an ohms burn, which pushed the Discovery the remaining way into orbit. The spacecraft is in an orbit fairly close to circular at about 160 nautical miles in altitude. A couple of problems that were observed and that are being addressed presently. One is a failure of the secondary thrust vector control mechanism of the left ohms engine. The ohms engines have mechanisms which control the direction that they fire, so that the thrust can be directed to move the orbiter. The crew always goes through a gimbal check, that is checking the movement of those engine nozzles after a burn, and the crew reported that on the left engine, the secondary gimbal system failed to test, and the primaries on that side and the primary and the secondary on the right all passed the test. Also a problem in work. The crew reported, and it was also noticed here on the ground, a problem with the flash evaporator system. We noticed that about an hour and a half ago, going LOS from the TDRS, that there was a drop in the temperature in the high load portion of the flash evaporator system. That's a cooling system that works primarily during ascent and entry to cool off the orbiter's electronics, and it also supplements the radiators while on orbit. That problem with that system is an indication there might be some ice perhaps on the duct where the steam from the operation of the flash evaporator system is vented overboard. The crew was instructed to switch to the secondary system on flash evaporator system, and it was controlling the cooling. Now, of course, that the payload bay doors are open, the radiators are carrying the cooling load. But the flight controllers will continue to troubleshoot that and evaluate it to determine whether or not there is some ice in that system and what effect it might have on the operation of the mission, what effect it might have on all the activities that have to go on, and if there is any concern for the future operation of the flash evaporator system later in the mission. Again, Discovery is on orbit and the doors are open. The crew is getting out of their suits, going through the post-insertion timeline, getting all the switches configured, all the orbiter systems set up for orbit operations, and they have been given a go for orbit operations from Mission Control. We're counting down to a payload deploy of just under 4 hours from now, where the crew will eject the tracking data relay satellite and its inertial upper stage from the cargo bay. At 2 hours 13 minutes, this is Mission Control, Houston.
Discovery, Houston. 2 minutes to LOS Tidris. We'll pick you up at Yargady in 11 minutes.
Okie dokie.
This is Mission Control, Houston. We will be having some downlink television on Orbit 3 through the Hawaii station. We expect that to be at about 1:30 Central Time, and that will be of the pre-deploy activities for the tracking data relay satellite and views out through the payload bay. We're in a loss of signal period right now, the Discovery out over the Indian Ocean. Part of the way, about a quarter of the way through orbit number 2. And we'll pick up again in 3 minutes and 20 seconds through Yargady. This is Mission Control.
Discovery, Houston, we're with you through Yargady for 7 minutes.
Roger, Houston.
Discovery, Houston, we're about 1 minute and 30 seconds to LOS Yargady. We'll be handing over to the Orbit 2 team at Guam in about 6 minutes. And we just wanted to pass along to you that we hope that you enjoy the next 4 days. You've certainly earned them. And we'll be talking to you on day 4 for the FCS checkout.
Okay, Houston, we copy all that, and we sure appreciate y'all getting us on up to orbit the way we should be. And we're looking forward to the next 4 days. We think we've got a lot to do and going to have a lot of fun doing it, and we'll be ready to come back with y'all.
We'll talk to you then.
Discovery, Houston. Your Orbit 2 team is with you through Guam.
Hello, Houston. Loud and clear.
You're 5 squared also, and we have a preliminary deploy time for you when you're ready to copy.
Okay, we just picked up an echo there. Stand by on the preliminary deploy pad. Go ahead with the pad, Lacey.
Okay, your preliminary deploy time, 6:13:02. 6 hours, 13 minutes, 2 seconds.
Copy, 6:13:02.
That's it. Also, we'd like you to take TV to command. We'll be looking over your shoulder at Hawaii, selecting views only.
Houston, Discovery, I got your IMU align log if you need to copy it, if you didn't see the data before we did the alignment.
Okay, go ahead with that, please.
Okay, Lacey, the star IDs were 48 and 28. Angle error was 0.01. Delta angles, X was minus 0.01, plus 0.03, minus 0.02. Delta Y's plus 0.01, plus 0.06, plus 0.06. Delta Z's minus 0.11, minus 0.06, minus 0.05. Execute time was 2 hours, 42 minutes, 45 seconds. Over.
Okay, we copy that. Thanks a lot, Dick. Discovery, Houston, we're 30 seconds to Guam LOS, and we'll see you at Hawaii at 2 hours and 53 minutes.
Okay, we'll see you at Hawaii then.
This is Mission Control. We have lost signal with the crew through the Guam ground station. We'll pick up again through the Hawaii station in about 6.5 minutes. The Orbit 2 flight team, led by Flight Director Chuck Shaw, has assumed control of the mission, and the crew has been given their preliminary deploy time for the tracking data relay satellite. That preliminary deploy time is mission elapsed time 6 hours, 13 minutes, and 2 seconds. This is Mission Control. This is Mission Control. On the upcoming Hawaii pass, we're expecting some downlink TV of the payload bay of the orbiter, and that's coming up in about 2 minutes.
Discovery Houston, we're with you through Hawaii for the next 8.5 minutes.
You're loud, Lacey, with about a 2-second delayed echo. Maybe 1 second.
This is Mission Control. Our payload bay camera view is of the nozzle of the inertial upper stage.
Houston, your go for internal power transfer. How do you read me now, Mike?
That's much better, and go for internal power.
Roger that.
Lounge has received the go-ahead to transfer the IUS to its internal power in preparation for the payload data checkout of the IUS. It's one of the early checks before deployment of the satellite.
Discovery Houston, your go for the pre-deploy checkout.
Roger, go for the checkout.
This is Mission Control. Lounge is beginning the pre-deploy checkout of the inertial upper stage. Later, a little later in the timeline, he'll also do a pre-deploy checkout of the tracking data relay satellite itself. This is Mission Control. The nozzle is being gimbaled, moved by as part of the process in the pre-deploy checkout for the IUS.
Houston, Discovery, pre-deploy checkout complete. We were on the batteries for 5 minutes.
We copy that, Discovery, and Sunnyvale confirms a good pre-deploy checkout.
This is Mission Control. Following that successful pre-deploy checkout of the IUS, the next step in the checklist is a direct check of the IUS. The Sunnyvale ground station will be sending commands to the IUS as a checkout procedure to make sure that the IUS is able to receive commands properly before it's deployed from the payload bay.
Discovery, we're about 30 seconds to Hawaii LOS. We'll have about a 1-minute dropout while we hand over to Tetris.
Roger.
And Mike, Sunnyvale standing by for the direct check.
Okay, going to RF now.
This is Mission Control. We'll be back in voice contact with the crew in 30 seconds over the tracking data relay satellite. And Mission Specialist Mike Lounge had begun the procedures for the IUS direct check. During that check, the upper stage, the inertial upper stage, will receive signals directly from the Sunnyvale ground station, its control station, as a verification that the stage is able to respond to those commands before we deploy it. The next step in the checklist following the IUS direct check will be a checkout of the IUS through the payload interrogator aboard the shuttle.
Discovery Houston, we're talking to you through Tetris now for the next 51 minutes.
Sound clear.
Discovery Houston for Dick.
Go ahead, Houston.
Roger, Dick. ECOM's seen 3 good cycles on the cryo heaters now, so over on R1, we'd like you to take the O2 and H2 tank 3 heaters A and B to off, please.
This is Mission Control. Our next TV will be a change of shift briefing with off-going Ascent Flight Director Gary Cohen. That briefing will begin at 2 p.m. Central Daylight Time and will originate from the Teague Auditorium at the Johnson Space Center. That's scheduled for 2 p.m. Central Time with Ascent Flight Director Gary Cohen. This is Mission Control.
Discovery Houston, commanding is complete.
Roger, we saw it.
This is Mission Control. Capcom Lacey Veach let the crew know that the Sunnyvale ground station completed its direct check with the IUS. This is Mission Control. The communications officer reports that he sees that the payload interrogator is locked on to the IUS And that means that that portion of the checklist is in process. This is the last step in the pre-deploy checkout with the IUS, and that check is through the orbiter's payload interrogator to confirm signals can be sent to the IUS. The next step that we're expecting about 10 minutes from now at about mission elapsed time 3 hours and 20 minutes will be the payload interrogator checks with the TDRS, the Tracking Data Relay Satellite. As soon as the IUS payload interrogator checkout is completed, the crew will move on to do the PI checkout with the Tracking Data Relay Satellite.
Houston, Discovery.
Go ahead, Discovery.
Roger, we've been having loss of telemetry from the IUS dropping in and dropping out on 16 kilobits RF. I don't know if you've noticed that or not, but we lost it there for about 20 seconds at one point. It's come back in now.
Roger, we copy that, Dave, and we'll be looking at that.
Okay, and we're ready to go back to 64 kilobits.
Okay, stand by one. Discovery, Houston.
Go ahead.
Roger, Dave. We saw the dropouts down here, and just momentarily, we've had a good lock ever since that momentary dropout, and we're happy with it now. We're ready for you to press on with the checklist and go to 64K.
Okay, and work. Houston, Discovery, the Cryo O2 tank heater sensor check was completed and checked good.
Okay, we copy that. Thanks, Dick.
Lacey, also the lamp and fire suppression test was completed, no anomalies.
Okay, we copy that. Thank you.
And Houston, USPI checks are complete.
Roger, Discovery, we copy.
This is Mission Control now that the payload interrogator check with the IUS is complete. They will move on, the crew will move on to payload interrogator checks of the Tracking Data Relay Satellite. During this check, signals are sent to the TDRS from the White Sands ground station through the payload interrogator on the shuttle.
Houston, Discovery, we have good signal presence and command lock on the TDRS.
Okay, thank you, Dave. Discovery, Houston, White Sands will be starting their PI checks momentarily.
Okay.
This is Mission Control. The White Sands ground station has begun transmission of the commands through the payload interrogator on the orbiter Discovery as part of the preliminary checkout for the Tracking Data Relay Satellite. The reason for these pre-deploy checks is to make sure that both ground stations can get the computer commands into the vehicles so that they will respond properly once they have been deployed from the shuttle.
Discovery, Houston.
Go ahead, Lacey.
Roger, Dave. White Sands has completed a good TDRS PI check, and you're go to secure from that.
And work, thanks.
This is Mission Control. The communications officer confirms that the crew has turned off the payload interrogator. They have had a good payload interrogator checkout. White Sands Ground Terminal has confirmed this. Coming up at 2 p.m. Central Time, we'll begin our change of shift briefing with off-going Ascent Flight Director Gary Cohen. That's at 2 p.m. Central Time, originating from the Teague Auditorium at the Johnson Space Center. This is Mission Control.
Houston, Discovery.
Go ahead, Discovery.
AMU data take 32630.
32630. Thanks, Rick.
This is Mission Control. The crew was referring to an attitude match update. That data was taken just a few minutes ago by the crew, and that helps to make sure that we have the right attitudes for the shuttle as well as the IUS upper stage before we deploy it. The next milestone in the checkout of the IUS and TDRS before deploy will be transfer the state vector to the IUS, and that's scheduled for about 4 hours and 18 minutes into the mission, which is roughly about 50 minutes from now. And then the crew will maneuver the orbiter to the right attitude for a direct check with the TDRS tracking data relay satellite, and between that satellite and the White Sands ground station. This is Mission Control.
Houston, Discovery.
Go ahead, Discovery.
Roger, we performed the app control and checkout. All looks good.
Okay, great. Thanks, Dave.
This is Mission Control. The crew is still working through their checklist, and the next milestone that we're looking for in the preparation for deployment of the tracking data relay satellite will be the transfer of the correct state vector to the IUS, the inertial upper stage, and that is scheduled for about 4 hours and 18 minutes into the timeline. However, that may be done early if the crew is ready for it. We're about 5 minutes from LOS on this TDRS path. Mission elapsed time 3 hours and 49 minutes. This is Mission Control.
Discovery, Houston.
Hello.
Hello, Discovery. You've got a good state vector on board. You are go for the state vector transfer. And as soon as you've completed that, you can proceed on with your maneuver.
Okay, sounds good to have that early. Thanks.
Raj, yes. You can go ahead and maneuver early if you want. Once you have once you confirmed a good state vector transfer.
Roger.
Discovery, Houston, radio check. Discovery, Houston, in the blind, we're about a minute and a half to TDRS LOS. We'll see you next at Guam at 4:15. Discovery, Houston, radio check. Discovery, we're getting some dropouts here as you maneuver. We're about a minute to LOS. We want you to delay APU cool off. We want you to delay that until we give you a call on it. And we'll see you at Guam at 4:15.
Copy, delay the APU cool. We got a good state vector transfer. We'll see you at Guam.
Roger that.
And it was 3:52:15 on the AMU data take.
Okay, thank you, Mike.
This is Mission Control. We've lost contact with the crew over the tracking data relay satellite. We will come up again over the Guam ground station in about 17.5 minutes, and we will have a summary in a few moments of the major activities that have taken place during the last Hawaii and TDRS passes. This is Mission Control. This is Mission Control at mission elapsed time 4 hours. During this last Hawaii and TDRS pass, the crew moved through the checklist very rapidly on the preliminary pre-deploy checks for both the inertial upper stage and the tracking data relay satellite. For the inertial upper stage, the rocket that will propel the satellite into its geosynchronous orbit once it's deployed from the payload bay of the orbiter, the pre-deploy checkout was completed. The IUS direct check between the IUS and the Sunnyvale ground station, and the IUS payload interrogator checkout, which sends signals from the ground station through the payload interrogator of the orbiter to the upper stage. All of those were completed successfully and reported to have gone very well. Also completed was the payload interrogator checkout with the tracking data relay satellite. The crew reports that they received good state vector and had good state vector transfer from the orbiter over to the IUS. The Sunnyvale ground station also confirmed that. The crew was given the go-ahead to begin their maneuver to TDRS direct check attitude, and that's a few minutes early in the timeline, about 20 minutes, but it's good to go ahead and get that done. The crew will be doing that direct check over Hawaii and Goldstone on the next orbit. Here in the Mission Control Center, flight controllers are beginning to review the go, no-go cue card. This process is followed before the deploy of the payload, and all the flight controllers are checking their orbiter systems, payload systems, and so on to make sure everything is set and in order for that deploy. The preliminary deploy time was given to the crew of mission elapsed time 6 hours, 13 minutes, and 2 seconds, which translates to 4:50 p.m. Central Daylight Time. And that is 2 hours and 10 minutes from now for deploy of the tracking data relay satellite. The crew has completed most of the checklist up to that point of the direct check, which will be coming up over Hawaii, as we said earlier. The environmental control officer here in the mission control room got a data dump from the orbiter over this last TDRS pass, and this is the information he needed to continue analysis of the problem that was experienced with the flash evaporator system early in the flight. While that system is not needed on orbit because we have the radiators to cool the electronics and the systems in the orbiter, it is needed during ascent and entry. So the flight controllers are still looking at that problem. There are several workarounds that can be done. One of the things is that you can warm up those nozzles a little bit and make them work properly. Also, the orbiter can be moved to a different attitude to allow the sun to shine on that side and perhaps thaw those nozzles out that presently ground controllers think they are frozen. However, they are analyzing data right now, and we'll have further information on that as they continue to study it. We'll be coming up on the Guam station in about 10 minutes. This is Mission Control.
Discovery Houston, we're with you through Guam for the next 8.5 minutes. Discovery Houston through Guam for the next 8 minutes. How do you read?
Loud and clear, Houston. We're at attitude and we're about to start the Perla release and elevation to 29.
Okay, we copy that, Mike.
This is Mission Control. The crew confirms that they're in the direct check attitude, and the next item for them is to release the payload retention latch assemblies, the devices that hold the tilt table in place, and to drive the tilt table up to 29 degrees for the TDRS direct check. We're standing by to hear when they start that. It is scheduled for 4 hours and 30 minutes mission elapsed time.
Houston, Discovery.
Go ahead, Discovery.
I just wanted to make sure you heard us. We're just waiting for the light to get a little better before we start elevating.
Okay, we copy that, Mike. We're getting, our data is a little bit ratty, so we may experience some dropouts. I think we dropped out there momentarily when you tried to call us.
Okay. Houston, Discovery, 30 seconds to tilt table operations.
Okay, we copy that, Mike. Discovery Houston, we'll be looking over your shoulder again, and we'll be watching the elevation.
This is Mission Control. The MAX officer confirms that he sees the payload retention latch device is released and the dual motor drive is moving the IUS tilt table up to 29 degrees. The crew is a little bit ahead of the timetable on this activity, but it is no problem for them to go ahead and elevate the satellite to 29 degrees. The direct check itself will take place over the Hawaii ground station at about 4 hours, 55 minutes mission elapsed time. We expect downlink TV over the Hawaii ground station at about 3:06 p.m. Central Time, and that will be payload bay views of the IUS TDRS stack. We may be even able to catch some of the tilt table elevation. This is Mission Control.
Discovery Houston, 1 minute to Guam LOS. We'll see you at Hawaii at 4:29.
See you there.
This is Mission Control. Just before we went LOS Guam, the payloads officer confirmed that Sunnyvale Ground Station sees the tilt table going up at its normal rate. The time we expect the direct check to begin is at about 3:22 Central Time over the Hawaii Ground Station, and that's a mission elapsed time of 4 hours and 40 minutes. However, the crew has been about 8 or 9 minutes ahead on the timeline. They would have to wait till they are within range of the Hawaii Ground Station to begin that checkout. We're still set to deploy the satellite at 6 hours 13 minutes mission elapsed time, which is 4:40 p.m. Central Daylight Time. 4:50 p.m. Central Daylight Time for deploy of the satellite. And we are expecting payload bay views TV over the Hawaii Ground Station also. This is Mission Control.
Discovery Houston, we're with you through Hawaii for the next 8 minutes.
Lab clear, Houston, we're at 29 degrees. Elevation time was 3 minutes, 35 seconds.
Okay, we copy that, Mike. Thank you.
This is Mission Control. Our TV downlink will be delayed for about 1.5 minutes here at this pass while we get a data dump first, and then we'll have our payload bay views television. This is Mission Control. We are experiencing some data drops. We may have some interference with our communications due to some solar activity that is affecting the antenna at the Hawaii Ground Station.
Discovery Houston, your go for APU cooling off.
Roger. And Lacey, we've got the cabin TV set up if you guys want to take that.
Okay, we copy that, Mike.
I want you to know we're not having any cat up here.
Rick, we're still taking a dump that we had to get out of the way first, so we don't have TV downlink yet.
Roger.
This is Mission Control. Payloads officer reports that Sunnyvale confirmed the tilt table elevated to its full 29 degrees for the TDRS checkout at its normal rate with no stops and not moving too fast or too slow. The crew should be progressing into the TDRS direct check here in about 4 to 5 minutes.
Discovery Houston, we're 1 minute to Hawaii LOS. We'll have a short dropout before we see you through TDRS.
Roger.
This is Mission Control. We'll be picking up with the crew here over TDRS momentarily. We missed our TV downlink over the Hawaii station due to the payload or the data dump that was being sent down taking longer than expected. So we missed that TV opportunity.
Discovery Houston, we're with you through TDRS now.
Loud and clear.
Same here. Discovery Houston.
Go ahead, Lacey.
Roger, Dave, I have the deploy pad and the SEP burn pad for you whenever you're ready to copy reference pages of 1-9 and then 1-8 of the IUS deploy checklist.
Okay, give us a second. Okay, we're ready for the deploy pad.
Okay, Dave, stand by just one. Discovery, for your info, TDRS commanding is in progress, and here we go with the deploy pad for an orbit 6A injection. 256.4, 270.0, 0/05:33:02, 0/006:13:02. Window protect Omicron is 020.1. Read back.
Copy 6A, deploy pad. Pitch 256.4. Omicron 270.0. Initiate track 0/053302. Deploy time 0/061302. Omicron 020.1.
Good read back, Mike, and let me know when you're ready for the set pad.
Go ahead, Lacey.
Okay, ohms both. TV roll of 270. Trim loads -0.4. Positive 5.1. -5.0. Weight 205.749. TIG 00/28:02.0. Peg 7 targets. Positive 029er.9. All balls positive 008.0. Maneuver attitude 187.012.353. Delta V tote 031.0. TGO 00:17. VGOs positive 029er.72. Positive 000.03. Positive 008.64. HA and HP 178. Positive 162. Ohms gimbal checks, none. RCS interconnect, none. Down mode, 2 ohms to 1 ohms. Helium pressure vapor isles, A closed, B open. IMU deselect, NA. Down mode to min SEP. And I've got to go ahead and read back, and I've got a couple of notes about the trim loads and post-burn actions for you.
Okay, ohms both. TV roll 270, trims -0.4 plus 5.1 minus 5.0. Weight 205.749er. TIG 00.06:02.0. Peg 7s plus 029.9er. All balls plus 008.0. Maneuver roll 187, pitch 012, yaw 353. Delta tolt 031.0. TGO 00:17. VGO X plus 029er.22. Y's plus 000.03. Correction on VGO X, it was .72. VGO Z is plus 008.64. HA 178, HP 162. No gimbal checks, no RCS interconnect. Down mode 2 ohms to 1 ohms. Ohms U in reg. A is closed, B is open. IME deselects NA, and we also have MinSep down mode.
Okay, Dave, that's a good read back. You probably noticed the trim loads put the engines through the CG, and we're doing that because of the left ohm secondary gimbal problem. That'll cost us about 12 pounds of prop. So the burn will be 2 engines straight feed with the engines trimmed through the CG. And then after the burn, we want you to power off the left ohms gimbal.
Okay, power off the left ohms gimbal post-burn, and if we lose the primary TVC during the burn, you want us to keep burning on the left engine?
That's affirmative. We want you to continue to burn.
Okay.
Discovery, Houston.
Go ahead.
Roger, you've got good targets on board and target state vector on board.
Thank you. And we see our command lock and signal presence is gone. Can we assume the commanding is complete?
Stand by and I'll double check on that. Discovery Houston, White Sands reports a good direct check.
Okay, we're on into the IUSPI lock.
Sounds good.
This is Mission Control. We received word from the White Sands ground station that they had a good check directly with the tracking data relay satellite. The crew is now moving on in the timeline to the payload interrogator locking on to the IUS for an additional check in that system. Capcom Lacey Veach just read up to the crew the deploy targets and the separation maneuver targets. After the payload is deployed, the orbiter will move away from the IUS TDRS combination to make sure that it's a safe distance away before the SRBs fire on the stage to move the TDRS into its geosynchronous orbit. Also, the burn will be using both left and right OMS engines, firing through the center of gravity of the vehicle. That's a small change in the burn to protect that thrust vector control loop that had a failure on one of the systems earlier in the mission. However, it does have the backup, but we want to make it as easy on that as possible so that we can prevent any other failures if possible. We have about 39 minutes remaining in this TDRS pass. The crew will complete this PI lock with the IUS, and the communications officer just confirms that they see the PI locked onto the IUS. Deploy time is still set for mission elapsed time of 6 hours and 13 minutes. It has plus 2 seconds, and that would be at a central daylight time of 4:50 p.m., about an hour and 20 minutes from now. This is Mission Control.
Houston, we got a good IUSPI lock.
Okay, we copy that. We see that here on the ground. Thank you.
Houston, Discovery.
Go ahead, Discovery.
Roger, we're getting quite a bit of interference. It appears to be on UHF right now.
Okay, we copy that, Dave. We'll check it out and see if we can find where the problem is.
Okay, thanks.
Discovery, Houston.
Go ahead.
Roger, Dave. We don't think the UHF problem is down here. If it is bothering you a lot, you can go ahead and change frequencies. Let us know when you do that, if you decide to do that, however.
Okay, we got it back on now. Seems to be all right. Must have been just a transient ground station or something giving us interference.
What sort of interference were you getting, Dave? Was it static, or were you getting some voice?
It sounded like a loud chirping. Very random.
Okay, we copy that. And also, we have no changes to the go, no-go cue card.
Copy, Lacey, no changes.
This is Mission Control. That call to the crew, no changes to the go, no-go cue card, is a sign that everyone, the flight controllers and Mission Control, have evaluated all their systems, and everyone is go at this moment to proceed on in the checklist. The next event at about 5 hours, 10 minutes mission elapsed time is another TDRS direct check.
Discovery, Houston, for Mike. Could you give us the time you were on internal power during elevation to 29?
Stand by.
Okay.
That'd be 4 minutes and 55 seconds, Lacey.
Okay, Mike. Thanks. Copy 4:55. Discovery, Houston, that S-76 comm message is a camera over temp.
Roger, Lacey. We turned them off to rest them.
Okay, thanks, Mike.
This is Mission Control. In about 12 minutes at mission elapsed time 5 hours and 30 minutes, or 5 hours and 35 minutes, the orbiter will begin to maneuver to its deploy attitude. The official deploy countdown is scheduled to start at about 5:45 mission elapsed time. So far, all of the checkouts of the payload and its upper stage have gone very well, and flight controllers have been pleased with the data they've been getting. So far, the direct checks of both the inertial upper stage and the tracking data relay satellite have been good. The checks through the payload interrogator on board the orbiter have been good, and it looks like everything is proceeding very well toward a deploy scheduled at mission elapsed time of 6 hours and 13 minutes, which is about 53 minutes from now. At the end of this TDRS pass, there will be a mission directors conference, and that conference involves the Sunnyvale flight director and the White Sands flight director, the mission director here at the Johnson Space Center, and the flight director and the payloads officer here in Mission Control. These people all have a pre-deploy meeting on the flight loops to check out on the status of the payload and make sure that everyone is in agreement to go for deploy. At mission elapsed time 5 hours and 20 minutes, this is Mission Control.